All right, let's do a little bit of a check here. We'll jump over to our streaming section. You guys should be able to hear my voice. You guys should be able to see my screen, so that's good. And we're going to do a little bit of the Socratic method. I've been adding to this. There's 117 slides now in our questions that we ask ourselves about systems and the different things that we do here. So we're going to, for me, I'm going to jump into one of my Linux boxes. You guys can jump into any of yours and really do whatever you want, or just kind of watch. And I got the notes in the bottom right because we always add to the notes as we go. People always have new fun little ways to figure out things about the system. So we'll look at that. And, basically just let me know if you guys have questions. We're not working super hard. It's Thursday night. It's my last night out of last night out of Phoenix. I'm in Ohio right now. I'll be leaving here and flying out. I did have to spoil myself, and I did upgrade my flights. So I've just been having such terrible time on airplanes as far as it's just brutal. So I've decided to kind of jump up a little bit. Oh, that's interesting. More than one ingestion is using primary URL. Send one stream to the primary. Uh-oh. That's not good. Hey, Hack the Planet, how's it going? Thanks for the raid. We are not working too hard. Or Hack the Planet, was that you? No, it was Hack Smarter that raided me last night. But you've raided me before, I think, if I recall, or maybe I'm just thinking of somebody else. But Hack Smarter raided me last night. So, hold on real quick. I gotta check my OBS for a second. I need to look at my docs. Maybe I did multiple output. Oh, that's okay. Let me stop one of these, and then that'll make my YouTube a little happier, because I had two different outputs going to the same YouTube. So give me 1 second here on YouTube to refresh that and make sure that the stream looks happy. Yeah, all right, good. We'll just leave it as it is. All right, Akshunya, the weather has been insane. West is burning, east has snow. Yeah, Akshunya, we had to fly around we flew through the Gulf of Mexico to get to Atlanta the other night, and then I hear today about how people are talking about changing the Gulf of Mexico to Gulf of America, and I'm like, oh man, politics. I'm going into data centers and getting completely locked out from any phone or other types of access, So it's kind of a funny thing. All right, so we're gonna do a little bit of this. If you guys, yeah, the Gulf of America, that's exactly what it was. So, all right, so we're gonna do this. If any of you guys want to try it along with me, there's always the answers at the bottom. But really, this is an idea of the Socratic method is a method of asking questions about a thing to make sure that you understand it. This is not just me telling you how to do something or somebody giving you the answer. It's more like you should try to think through and figure out all that stuff. I'm actually setting up air gap. I was actually on quite a few AI servers today, yeah. And they're more than air gap. They're completely They're completely gone. They don't ever touch the world. In fact, when things go in those data centers, they never come out. If it's not volatile, so if it's a non-volatile type memory, it never leaves. It's only destroyed. So it's very sad for disks and those kind of things, but if you're going to store data and walk out of there, you get destroyed. So, all right, so let's talk. We'll start with CPU topics. And the first one is, can you list the number of CPUs in a box? So if you're on some server like Rocky 5 here, can you list all the CPUs that are there? And obviously the answers are on the right, but if you know of any to add to it, we'll add them as we go. These notes and this presentation are up in the Discord, so if anybody wants them, you can have them. But yeah, we should be able to see LS CPU. Oops. We'll list CPU information, and I'll see that there's 2 CPUs, so LS CPU would of course work. Lots of other information about the different flags that are built into the chip, which may be useful for different types of tooling that I'm using, or different types of compilers are going to be able to handle these flags in different ways. And there's errors that are known, and all kinds of things that you might need to look at this for if you're really digging down into systems engineering. If you're just an admin and your servers have been running for 12 years and you guys are just keeping them running until the next ones come up, this might be a little less interesting to you. But if you're like pushing the envelope of like newer systems and stuff, this is good to know. Okay. Yeah. So I have other ones over here, but yeah, let's go with NPROC. NPROC is listing just the number of CPUs. I like to do catproc CPU info back in the day, and then you can grep-i for proc. And that would give you 2. Now you might get away with DMID code. Let's just do all of that and then grep for like CPU. And yeah, that gives you 2 socket designations, so that would be good. Your system has 2. You got to remember this is a virtualized machine, so he's only getting the sockets that are shown to him because this is a virtual machine. I'm in Ohio, but I'm connected into my home lab at home. A bunch of you guys down in the Discord know how to get into the home lab as well. Also, I'm going to link the Discord just because I think, I could spell. There's our Discord over on the Twitch side if anybody wants to go hang out with other engineers and people that are kind of interested in doing the same stuff as you maybe are. So there's that. I'm in Dayton, but I'm leaving tomorrow. I got to go in the office and then I'll be in the data center all night and then I'm going. So yeah, I'm in Dayton. I'm working out of one of the customers out here. They've got a few skiffs working similar stuff to like what some of our other systems out here are. So just down the road. Yeah, Hack the Plan. I'll let you know next time I'm in town. In fact, I might be in town in a month again because I might be out here training these guys. So I'll make sure I let you know. I will. That'd be good. I don't mind seeing everybody. Although next time I come out, I think the wife wants to come, but that's still, it's not a big deal. Go grab some food somewhere. All right, so this one was fun. Somebody wrote this one last time we did this, so I'm going to grab this one. And it was if you're using Python 3, so let's make sure which Python 3. Yeah, I can't tell you exactly where I'm at, but that's not a bad guess, Hack. I'm in the vicinity, sure. I have many customers that are military and DoD related. But yeah, I'm in that general area for sure. Actually, I just messaged one of my buddies who was out here and I said, hey, I'm in the general area. Is this where you were at when you were in the Air Force? And he goes, oh yeah, I was out in that general area. And I was like, okay, that makes sense. I've been kind of disoriented out here anyways because I came in a blizzard. In fact, when I got off the plane, I heard the pilot. He was talking to one of the guys at the front, like he was greeting everybody and saying bye. And he looked at the like the head guy that had been running the I don't know, I guess stewardesses, whatever they call them. I'm not sure exactly what the technical term is for that anymore. But he said, hey, I've never landed on a runway full of snow like I just did right now. And I actually was thinking it was one of the more, it was in the last year of all my flying I've done, he probably had one of the better landings. I wouldn't have known that he had just landed in a foot of snow. And you say, really, even with them burning it off? And yeah, he said he landed in more snow than he's ever landed in. So I thought that was interesting. So, but yeah. So that's that. All right, this one's fun. Hold on, let's run this one. So we see that we have Python 3 on our system. We can dig in, right? You can always dig in. Once you know how Bash interprets, this is where Bash is going to go because it found it in the path. You guys know this stuff. And if you don't, well, absorb it, right? Because this is the kind of stuff that you guys need to know. Yeah, and then I tried to walk around the mall out here, Hack the Planet, and it damn near killed me. Because it was like 2 feet of snow on the ground, and they were like plowing the parking lots and stuff. It was wild. It was a wild amount of snow. And I was coming out of 75-degree Phoenix, Arizona, so I was not ready for. I don't think it's been over 28 the entire time I've been here. In the middle of the day, I don't think it's been over 28 degrees, and that's Fahrenheit for you people that are using other systems. Yeah. I'm in a little place right now called Beaver Creek. I actually bought the wife a little beanie cap that's like Beaver Creek, whatever. One of the guys had lived out here. One of the guys I was working with from Dell. He had lived out here for like 19 years, yeah, because he raised his kids out here. And he took me to this little place out here called and a really good little pizza place called Marion's. So I kind of like that place. I guess they're kind of popped up around here. So that place is pretty good, little Marion's. So all right, let's run this one. Let's see what happens here. Python 3, and then it went in and it imported multiprocessing as MP, and then it printed out the MP CPU count. And that's actually pretty cool. We might be able to get away with running that command and just seeing all the things that MP might show us. We might be able to just see everything that MP would see. Maybe not. There might not be like an all or something. Nah. We can go look up what MP or what multiprocessing allows, right, for a print, and then we would just be able to print everything off of it. But apparently we can't do that. But we could print. We could go find the other things. I think there's probably some index of that or something like that. So yeah. So oh yeah, and it's yeah, this is a good little area up here. Although it is literally just covered in snow. Oh man. Okay, so can you list the number of CPUs? Yeah, and we used all these tools over here to do it. Again, if anybody wants this list and you're like, hey, where do you get this big old list? We just built it, hanging out on stream, talking, doing some Linux, and it's on the Discord. So if anybody needs this, it's up in the Discord. And what's the next one? The next one is, can you tell me the speed? Can you tell me the speed in megahertz of your CPU? So we clear the screen up, and we do maybe cat proc CPU info could be one, and that shows us how fast the CPU megahertz is, about 2.4 gigahertz. Not a super fast CPU, right? I'm using a slightly dated hardware, but that's not bad. That can still churn through workloads and run servers and stuff. So, you know, it does what it needs to. And then there's also, what other ones have we found for this? I think we did dmessage and then grep for like MHZ just to see if we could find the megahertz. And there's the processor. So as the system came up and was walking through its system bus, as the kernel was checking things out, it got alerted to a 2.4 gigahertz approximately processor, right? What about that dmessage again? Can we do dmessage? Sorry, not dmessage, a DMI decode, and look for maybe grep-i for MHZ again. No, we don't see that, but let's see what other things we came up with. Oh, dmessage showed it, DMI decode did not. LSCPU also lists out the CPU information, so that also tells us. There it is right there. 0.4 gigahertz. That's pretty good. Not bad at all. Nice little setup here. All right, can you tell me speed in megahertz? So we found that. Next one is, can you tell me the manufacturer of this chip? Well, there you go. We see it's an Intel chip, approximately Intel, being told through the hypervisor to the guest. Yep, we're genuine Intel. What about some of these other ones? We can do cat proc CPU info. There you go, boom. There's the CPU in megahertz and then the model name of manufacturer of the chip. Good. There's the vendor ID, genuine Intel. And then this one, I didn't know this one when I was first doing it. Oh, so we did megahertz, now we're on the manufacturer. And the first time I did this, somebody showed me LS show. I'd never seen this. grep-i for Intel. And oops, that might only be on maybe on that one might have been. Let's do what provides L show. That might only be on an Ubuntu type system. So we were on Ubuntu before, and now I'm kind of going through all of these on a RHEL type system, which is Rocky. Rocky is RHEL based, right? So LSHW might not actually be on here. It doesn't look like it is. I don't see the command anywhere. What? Oh, leave it all together. Let's see if this actually could be installed on the system. Oh, we could install it if we want to. So DNF install LSHW. And we'll see if it needs any dependencies. We'll just say yes, install it. And then we can always check which LSHW. There it is. It's under SBIN, so it's a little more locked down. ls-l user SBIN lshow. Right. And it is executable by anybody, but it's in user SBIN, so it's okay. And then LSHW grep-i for Intel. And that's going to go run through everything and then show me, yeah, that's more information about the system right there. But now I'm kind of curious. Let's do LSHW and with a more on it. Let's just see what that does all by itself. When it enumerates everything, what does it show us about the system? Oh, that's pretty good. It shows us the vendor is Zen, which is our XCPNG that we're on. Yeah, I can see all kinds of stuff. Look at all this. Lots of tasty data there that I can see about my systems and my CPU slots and my memory, any size, and if it's an ECC or a non-ECC memory, all my PCI bus information, what kind of devices are plugged in, and if any drivers are associated with them, which might be useful for me for troubleshooting. IDE tells me about disks. USB information if we have any USB connections. Yeah, pretty good. Lots of information, lots of stuff going on in our environment. It also gives us our network information, logical name is Z0, and then we can go look at information around, oh, there's our IP address too. So it gives us a lot of information right there. I hadn't really even used that tool before somebody brought it up the other day. In fact, I had never even went out of my way to install that tool. I think it was just on the Ubuntu boxes we did when we were first doing this. So now we've installed, right? We've installed that tool just to be able to play with it today. And then that's the kind of information that we got out for it. So yeah, can we tell how many CPUs are there? Can we tell the speed of them and the manufacturer? Yeah, very, very straightforward. Can we tell the architecture of this chip, right? So the system that we're on, we can do LSCPU, and we can see that it is 64-bit. It's x86-64. And another one that's kind of good is uname-m. Uname-m will do that as well. I don't know why I didn't have the uname-m on there, but yeah, can we tell the architecture that the kernel sees? Yes. Can we tell the architecture of this chip? Yes. Boom, right? And the point of this isn't for me to wow you guys with me doing it. It's for you to be able to think through and say, do I know how to do this thing, or do I need to spend more time with these pieces of, with this tooling? Do I need to spend more time with Linux because I've never done this before? All right, can you tell me the architecture? Can you tell me if this is a physical or virtual machine? Can you tell me that? Can you tell yourself that? Could you talk to this in an interview because everybody, everybody's goal is to get, well, not everybody's goal, but a lot of people, if you hang out with me at all, your goal is to get into Linux systems administration, Linux systems engineering. So I want you to be able to do that. So to that point, I want you to be able to answer these questions for yourself in the job, but also to be able to understand these things are the kind of things that somebody might ask you about. Are you familiar with checking if systems are physical or virtual? How would you know? If we didn't have it built into the name of the server, could you still go to a set of servers and tell that they're all virtual, right? And here's some commands. There's this lshow again. -c system. And that'll show you a bunch of information. And yeah, one of the things we see is that the product is HVM DOMU, and then it's Zen. So we know that Zen is a type of virtualization. So we're on a virtualized system. That is one indicator for me that I am on a virtualized system. Another one might be DMI decode -s system manufacturer. Zen, that's an indicator right there too. If we have virtualization tools on here, virt what will tell us, oh, so we don't have it. I may do a DNF install for virt what, and then say yes. And this will just tell you if you're on a virtual machine or not, right? So we come in here and we do a virt what, and it tells you, yeah, hey, look, buddy, you're on a Zen server. Zen is a type of hypervisor, or it's a type of, Zen is a type of hypervisor, but you are a guest on that Zen server, right? You could maybe mess around with LSPCI and see all of this stuff and look around for maybe like QEMU. QEMU might tell you. Or down here we see that we're on Zen source. That would kind of let me know that I'm probably on a Zen server. Here's my SCSI storage controller. That would be an indicator to me that I was on a virtual machine of some type. And then you might be able to get away with system D detect virt. And it'll tell you if you're on a virtualized environment or not. And it's nice if system D understands that, because that means that system D can take into account whether or not it actually has hardware interrupts, or if it's using virtualized interrupts that are going to be possibly waiting for their interrupts to happen, you know, that kind of stuff. The behavior of a system that is a guest is different than the behavior of a host system that actually touches the physical hardware, right? The goal is to make them not that much different, but the more your system understands that and is aware, the better your system's going to run. So it's good that system D might know what type of virtual, if you are in a virtual environment or a physical environment. So yeah, can we tell if the system's physical or virtual? Yes, we know it's virtual. We knew that because we looked in here. We did not necessarily, we didn't have to know that because I was the one who built it, right? Like, we didn't have to know, oh, that's in a lab environment, so Scott built it. Yeah, but what if I had just named it Jabberwocky? How would you know that Jabberwocky was or wasn't a physical machine? You got to use your tools, right? You got to get good at your tools. Some of these guests get pretty rowdy too. Yeah, well, all my devices do is just shut down and kick you out anyways, right? That's what the behavior's been. Just shuts down and kicks everybody out. So can you spin up the CPU to a high load for 3 minutes? Do you know how to do that? Well, we've got a tool called stress. If we don't have a tool called stress, we can install it. DNF install stress, right? That'll install the stress tool. By the way, if you ever get scared on one of these nodes, if you're messing around with them too much, if you just do a reboot, it will go to a wiped clean system every time. So, you know, my home lab environment, if you're ever in there doing ProLug labs or ProLug projects and you get stuck on something, you can always reset the labs. You can also just jump out and jump in another node, but I'm saying you can do it. Yeah, so let's just say stress-H for help. We'll just do -help. And it's going to give us a bunch of options. Now, we know from number proc that we have 2, and we know from like free-m that we have, you know, 4 gigs of RAM-ish. Some are already used and all that good stuff. But we haven't even gotten to the memory stuff yet. But so we sit here and we go, well, can we spin the system up? So we can say stress, maybe -CPU of 4. Now, we only have 2 CPUs, so we're spinning it up higher than we maybe should. And then maybe we say --timeout is 180, because that's 180 seconds. And then maybe we ampersand to put that to the background, right? And then we say while true, do uptime sleep 3 done. And we just sit here and we watch this system spin up on its higher load as that system runs in the background for stress. Cat dev ram into dev null, not as precise as stress, but we're gonna watch it spin up. Yeah, Raleigh, I haven't tried that. I do DD from dev random into, or dev u random typically into dev null. I've never tried catting dev random right into dev null. Will that just happen once, or will it? I've never tried just the cat into there. But you guys should see the system going in a higher load right here. And you might ask, well, what is this load right here? This is wait time against the number of kernels you have. So this wasn't under, there wasn't a wait to get to the system till right here, because we have see how we have two CPUs? Well, once you get over 2 here, that's considered bad, typically. Do you know the difference between my while and a watch? I don't know if I've ever tried a watch dash n. Is the watch dash n going to do the time? But why is watch different than what I did? Doesn't watch override every time? Maybe you wanted to see the escalation over time, right? Very possible. By the way, this is going to be done here in a second. Yeah, so my thing about watch is good when I don't care about previous output. But if I want to watch it climb, or if I want to go to lunch and come back and check on it, this is more what I like to do. Plus, I've been accused many times over the years by other engineers of just doing this shit on screens like this so that it looks like I'm busy. They may or may not have been right, but I don't care because the manager doesn't know what I'm doing anyways. The manager has no idea. But yes, I have been accused many times over the years of, Scott, you're just doing that because that's the equivalent of walking around the office with a notepad, like a clipboard. And I go, yeah. So, what are you going to do about it? I'm just kidding. I don't actually care. But here the thing is, we're going to see this fill up. It's still going higher in CPU. We're about to hit the 3-minute mark pretty soon here. And when that 3-minute mark is hit, we'll get a little alert to the terminal typically. And then we will watch this drain back out until this node is chilling. This node will go back to like a kind of a cool little mode. And then here were our different ways. Look, here are all the different ways that we had done this. Oh, somebody had done this one. This one was fun. See, there it finished. Now it's going to keep looping, and we're going to watch this number go down. From 3.81 at its highest, we're going to watch that number drain back out. Yeah, somebody had a good one. OpenSSL speed - multi $nproc. So a number of 2 or whatever. What's a C matrix? I don't know what that is. Just run a matrix. Oh yeah. Yeah, I didn't even think about it. I missed the top one, but yeah, it's like just run a script. Well, this to me, this is the equivalent for management, but a lot of times if I'm monitoring a system this closely, like I'm actually like intimately watching something happen with it, it's probably there's something going on, right? There's something actively happening that I care about, or a team has asked me to keep an eye on something as they spin up a Java process, or we're stress testing a system. And when you stress test a system, you have to break something. Some of you guys don't know that or haven't heard that. But as an engineer, if you guys run through a system and you try to spin it up as hard as you can, and nothing breaks, it just takes the load, you have only load tested your system and validated that your system can handle a load to a point. If you are going to stress test any system, you must break something. And the part where it broke is what failed the stress test, and that's the part that you need to work on, right? So wear a wizard hat, no one will bother you. I was walking around the Renaissance Festival years ago, and I had a jester's hat on, and one of the guys that was at the Renaissance Festival, like one of the actors that's there just kind of hanging out, walked up and kicked me in the butt, and I was like, whoa, what's that for? And he goes, because if you're wearing a jester's hat, you better be smiling. And I was like, I didn't realize I wasn't smiling. And then we got in a fist fight, but no, I'm just kidding. There was no fist fight. But he was right. If you're gonna wear a jester's hat, you need to make sure you're smiling. Or I also found out if you're wearing a jester's hat, you better be ready to tell a joke, because anybody there can ask you for a joke if you're wearing a jester's hat, and you have to be ready to handle that. So I think this year we're going to do. What is it this year? I think we're going to maybe like our 8th or 9th in a row Renaissance Festival. We go to all of them. We go every year out in Phoenix. It's always a good time. tools generate monitoring events, so we would have real bit. Yeah. Raleigh, that's exactly it. Like, we monitor. This is fine to monitor. The way I'm doing this, one of the reasons I tell you guys so much to work with Grafana and these other tools is because while this stuff is fine to show other engineers, you would like bore a manager or a PM, like a project manager, to death if you showed them this. They would be like, what is this? There's so many numbers. And you're like, well, look, they're just descending. And they'd be like, I don't know what a descending is. Use English, man. And you're like, all right, well, when one server loves another server, they generate this load together, right? All right, anyway, no, don't tell them that. That'll get you, those kind of jokes will get you sent to HR. But anyways, the point is, can you spin up the CPU high load for 3 minutes? Yes. Yeah. All right, so memory topics. So we get down here to memory topics. And I said, can you tell me how much RAM we have? So we're on a box, never been on this server before. Somebody's complaining about something, because these things happen. And we say, well, what is the heartbeat messages? I'm not sure what that is, local. And is that's some newfangled youngin' thing? It's funny. You guys know I'm the oldest of the millennials. That's one of the funniest things to me is like when I hear people talk about like millennial this and millennial that, I'm like, I literally don't fall into any of that. You can't give me a stereotype of the millennials that I fall into, unless it's like liking cartoons or something. But like, if you know any stereotypes for millennials and you want to ask me them, I guarantee you I don't fall into it. All right, so how much RAM do we have? We can do a free -M to see the memory. We can do cat proc see cat proc mem info, but this is gonna dump, guys. This is a mess. Yeah, when one server loves another, the heartbeat messages. Yeah, fair enough. Localkin, I don't know if you're retracting your own messages or the system's deleting them, but I'm not doing that. So if it's deleting your messages, I apologize. All right, guys, look at this. So that's a lot of info, and it's not super useful. I don't like cat proc mem info. This is one of those lessons where you can read stuff out of proc raw if you want to, but a lot of times people recommend that you use the tool. This is one of those times where I would highly advise, don't get into looking at stuff like this. You're just going to hurt your eyes. Look at it with the tools that are available to you. Does that make sense? So, some people like HTOP. I don't think I have HTOP on the system. Some people like ATOP. I don't think I have ATOP on the system. Some people like regular top. I have regular top. Just top. And the one thing I like to show you guys, if you are going to use top, not a lot of engineers spend a lot of time in top, but administrators do. So if you're an administrator, learn how to use top and look at it. There's a little H button. You can hit H. And the only one of these that I ever have used is this line right here. You've got L to look at the load average. That's your CPU. You've got T to look at your tasks in CPU and to order by those. And then M for memory. So I'm going to hit Q. And I'm going to say I want to look at this by load average. So what system is using the most load? What CPU is the highest, right? That's what it's going to order by, is this column right here, CPU. But maybe you're like, CPU is never running high. We're a Java shop, and we use Java virtual machines all the time. And what we do is we run out of memory all the time. So then you hit the M button. And M is going to look at memory, and it's going to show you which device is using the most memory on the top. Do you see this? This is what device is. So Promtail is using some memory right now. And the reason it's using memory is because it's reading from log files as they're being written to. And then it's sending them off to, it's sending our logs off the server in real time, right? That's one of the things we do in Home Lab here. So we get all the logs off in real time so that if anything happens, if anybody breaks a server on purpose, we can go find them and make sure that they're not, allowed in our little clean environment anymore, right? Because this is our Home Lab. This is where we work on stuff. It's our little Prolog lab where we build stuff and do whatever kind of fun stuff we want, right? And then this was one somebody showed me, NeoFetch. I think NeoFetch is there on most machines. Maybe not. Maybe this one's not. But DNF install neo fetch. Somebody showed me this one. I think this one was actually pretty cool if I recall. Oh, look at that though. When you go to install something and it wants 178 packages, 139 megs, you're like, well, I hope it's good. I mean, what is it mostly built on? Let's see if we can find what it's mostly using. It's using GTK 3 and 2. It's using ImageMagick, so let me see. I have no idea what Mesa is. I have no idea what URW is. But open JPEG. Those are some drawing things. I don't know what it's doing. Hey, how's it going, Categorian? We're just hanging out and working on Linux. We're using what's called the Socratic method to ask ourselves questions and figure out if we can answer them, that kind of stuff. Let's install it. What's the worst we can do? Break this box? We'll just reset it, right? But let's install this thing. That's 139 megs total. I think there was more with the dependencies. Some of you guys that have been around and know how my environment works, you know that when we're done with this, all we do is reset the machine and it'll go back to a clean, brand new machine again. So, yeah, we haven't had anybody use the student thing in a while, Categorian, so thanks for coming by. We are, again, yeah, we're just walking through and asking ourselves a bunch of questions and then going through the notes. By the way, I have these notes up in the Discord of, hey, can we build, you know, we're looking at, you know, how much RAM we have, all these different things, but can we answer these questions that we're asking ourselves? And the reason we ask them to ourselves now is because we're going to get asked them, or we're going to have to go figure this stuff out when there's a problem with the system or when we're building a new system and we need to know how our tools work. So I tell you guys, a lot of the times when you're learning systems, the Socratic method is very effective for just asking yourself, do I know how to do this? And if you don't know how to do it, like we don't know how to check the RAM, we go figure it out. Let's try this NeoFetch. Oh, that little guy. That's pretty special. Look at him. Just gonna leave that up. I'm all done talking about stuff. I'm just gonna leave that up now. That's pretty cute. I bet NeoFetch has a bunch of little options and stuff. But yeah, could we tell how much RAM we have? Yes. I think we can do that. Now, can we tell how much RAM we have used? So, we have free. -M makes it easier to read. And we have about 1 gig of our 4 gigs free. We've used 2,873 yeah, those should be megs. Yep. And as we sit here and look at this, we go, yeah, this system's not under terrible memory constraints right now. It's got enough to handle some more of whatever it's doing. What it is doing, we can go find out, right? We'll go look at. Did I see the CES reveal for the NVIDIA Digit? No, I saw a CES reveal for, what did somebody show me, Hack the Planet? One of our guys showed me this. You know what? One of the most annoying things about being on the road. So I'm on the road, and every time I go to do anything, it like resizes everything in this other window. So, all right, hold on, let me show you guys. Somebody posted down, maybe in our, where would they have done it? HPC topics? No. Oh, AIML, I think is where they put it. And they said, no, it was Fisherman that talked about it. I don't know where he put it, guys. I'd have to find it. But it was, I put it off topic too. You put it in general. And then the other thing too is I hate that these got all moved around, but what can we do, guys? For M-Pesa. That was sudoers. No, I can't find it. Anyways, he posted that they had put this new, yeah, Discord is just so... So bad. Just so bad. See? This is all old shit from him. It's like, give me the newest stuff, and none of the stuff is the new stuff from him. None of those things are anything that he's posted. Unless it's user. User? I don't know. I don't know. I thought there was like a user. Somebody, yeah, they just did. Hold on. They just did one that was like about a $3,000 box. Not their really tiny one. It was more of like a desktop type one. Is that the one you're talking about? One of the guys just linked to it. Yeah, maybe it was this Digits. I didn't realize it was called Digits. Project Digits. 128 gigs of memory. Developers prototype fine-tune and inference large AI models up to 200 billion parameters locally and seamlessly. Oh, okay. But what's the one that he had? The one that he was showing, the one that got linked. Oh, is it from? Let me try this. Hold on, because his was about a $3,000 box. From, I thought it was Fisherman Guy, bro. Yeah, fuck it. Yeah. But I just want to see. Starting at 3,000. Yeah, so maybe this was the same one because he said it started around 3K. 3K is not outside of the Prolog budget for us if we wanted to run some of our own lab stuff. I was telling them, oh, you know what? Hold on, because I said budget. Hold on, where did they post this crap? Wait a minute. Hold on, I said budget for sure. Here it was. Yeah, it was called Digits. Yeah, I knew Fisherman did it. What channel are we in? Oh, it's Home Lab Chat. Okay. Because he said, I need to find one of these for the Prolog environment. And I said, I'll move some stuff around and then we'll look at this year's budget. But I've been, by the way, guys, I've been on not vacation. I've been on travel for work. So I've been out of the state of Arizona. When I get back, I got to organize a few things, and then I got to cover a few things that we were doing with some of our different engineers in the group. And then I'll think about, like, because we haven't spent any money on the home lab for a while, so that might be a good one to kind of build up. NV link multiple digits together with an RDMA for increased capacity. Yeah. Hack the plant. That would be good. Yeah. And we'll probably just use it to make it tell us jokes or something, or run one of those streams with Seinfeld in it. Yeah, that's not bad though, man. Starting at 3K is pretty reasonable for like for labs. That's nothing for like labs and researchers and stuff. You get a research grant for 100K on some project or something, or some company asks you to look at something. You can reasonably say, hey, I need 30K to get 10 of these, and most companies wouldn't even blink if they're asking you for stuff. And Local Ken, I don't know if you're the one deleting those, but it just keeps telling me your messages are retracted on YouTube. So I apologize if that's deleting them for you, but I don't know. All right, anyways, that's fun. I mean, that looks interesting. I could get in there and play with it. Yeah, Hack the Planet. I don't think Intel's going to be super happy with some of the stuff that's coming out. So most of you guys probably know NVIDIA already kind of has a stranglehold on high performance compute. And you might say, what do you mean by that, Scott? Well, what I mean is, in the high performance compute world, we care about this same CPU and GPU and memory stuff that everybody else cares about. Most of you guys that are doing systems care about those things. But we also care about very high speed, low latency, typically directly to memory connected networks, and also back-end storage. Well, the networks, all the fastest networks run on InfiniBand, and InfiniBand was developed by a company called Mellanox, and Mellanox was bought quite a few years ago by NVIDIA. So NVIDIA controls the GPUs and the fastest networks on planet Earth, right? Yeah, Mellanox and RDMA. RDMA goes right past the kernel and all of the stack of the kernel and goes right to memory. So RDMA is super fucking fast, right? And that's what a lot of that's all based on. So where I'm going with that is in the high performance compute world, there's another one that's coming out soon. NVIDIA and is it Dell? And they're putting out a chip here soon. That's its name. I can't remember its name or not. I know I'm building a high performance compute system on it here this year. It was next year a few months ago, but now it's this year. And it's going to be one of the fastest in the world when we debut it. I think it's got about 180 racks in it. It's a pretty big system, pretty beefy system. It's going to be memory's always been across the bus from GPUs, and that's always been a limiting factor in like HPC speeds. But the memory that was always available to CPUs directly, the GPU is going to be sitting on the same processor set with the CPU, and it's called a what the hell's the name of that? Yeah, it's going to be on there with it. It's I keep wanting to call it like some Western chick's name. They've got this name for it. No, you're fine, Local Ken. I keep seeing your stuff getting deleted, and I just wanted you to know it wasn't me deleting it over on the YouTube side. I just keep seeing message retracted, and I'm like, is this guy's stuff getting deleted? Like on Twitch side of things, Nightbot goes rampant sometimes and just kills everything. I've seen it delete like 400 messages in a row before. I'm like, me and that guy have been talking for like 10 minutes or whatever, and it just deletes all their crap. So it's like, you've been spamming the channel. And you're like, no, that's not what happened that I remember. Oh, Runamucker, it's going to be interesting. It's going to be, man, I keep thinking it's like not Dolly Parton. There's like a name for this chipset that's coming. That's it's almost like a Western name, but I can't, like a Western female's name, but I don't remember what it is right now. So when I find out and can talk about it, I'll let you guys know. I just don't know what the name is right off. All right. Can you tell me how much RAM we have free? We know that. Can you show me how much swap we have? Well, we're not using swap. We know that. But we understand that. And do you know, and the follow-up question to this would be, do you understand why we don't want swap anymore? Do you understand why a Linux system wants to swap, but do you understand why we shouldn't swap? And databases love to have a bunch of swaps set up for them, but we do not ever want to be swapping in a Linux kernel. Linux systems should not swap. That's all there is to it. They want to swap, but we don't want to let them. Thrashing kills speed, 100%. Yeah, if you think of your CPU, right? Your processor on a system relative to the rest of the system is a value of 1, right? Let's just say however fast your CPU is. Let's say your CPU is 10 times faster than mine. We'll call that 1. And then however fast my CPU is relative to itself, we'll call that 1 for me, if that makes sense. So no matter what server we're on, we can think of the processor as a speed of 1, right? When you have to write out to RAM, your RAM is about 1/10, or what we call 1 order of magnitude slower than CPU. Now, CPU doesn't, and what I mean by that is RAM has to be accessed to come back to be processed across the CPU as instructions, right? So when we don't have instructions in local cache, like L1, L2, L3, right there on the chip, and we have to go read it, that is 1/10 as fast as just having it right there to run, is what I mean. But if instead of having it in RAM, from the RAM's perspective, if we need to go, the RAM will be now a speed of 1, if you want to think of it like that, then your disk, whatever disk you're using, even if it's like an SSD and it's fast, that is still going to be about 1/100th the speed or worse than RAM. So, your RAM is already 1/10 of your memory, and then now that's 1/100th of that, so it's a 1/1000th of the CPU at minimum, right? And my point is, yeah, thrashing is terrible. Anytime you're writing out to like page filing in Windows is what it's called, you do not want to be doing that on Linux servers. You don't want to be swapping. So, how much swap do we have? You can use your free -m and it'll do it for you. Now, I say, can you clear all of the free memory, all the cache memory? Do you know how to clear the cache memory of the system? My system has a fair amount of buffer cache right here. Could I wipe that and make it 0? And does it hurt the system to do it? Is it good to do every now and then, or does it not matter? Well, you're going to have to figure out that behavior, right? Depending on if your system actually uses its buffer cache or not, right? Echo. It's Echo Runamacher. It's on the bottom right there. It's Echo. You could cat that file too to see what's in there. You can cat it. It's a file. Everything's a real file. So watch this. Free -m, echo 3, and push that over into proc sys VM drop caches, and then immediately do your free -m again, and you should see, well, you should see that it is wiped. Proc sys VM drop caches. Yeah. Huh. Well, apparently we are using our buffer cache. So there we go. You can also use 2 or 1, and they do different behaviors of that. And you can go look those up if you ever want. But proc sys VM drop caches typically. I wonder if this is just, I don't know what's going on. All right, so anyways, let's go look at can you generate high memory load for 3 minutes? That's another one of these questions. Generate. Right. Can you generate higher memory load for 3 minutes on the system? Okay, let's see. We've got the same node that we were on earlier, and we should be able to do stress help. And we should be able to say stress, so free -m to see what we were playing with. And we should be able to say stress -VM, and we'll allocate, let's do, it says that by default they're going to be 128 bytes. Tells us that that's the, oh no, sorry, the typical worker is 256. Well, we've got free here, so let's try to do 4. And then timeout is equal to, we just do timeout of 180 seconds, right? And we'll ampersand that to put it to the background. And then we'll say while true, do free -m sleep 5 done. And let's just see if, yeah, as that thing's running, we're going to have less and less free memory on our system because we have created 4 VM allocations, right? And it says by default they're 256 megs. I would have thought this would have been a little lower. Maybe it's still allocating to them. But we should be able to see our system using more memory than it had been using. Hey Rob, thanks for coming by. Hopefully this stuff's useful to your guys. We're doing Linux with the Socratic method. I appreciate when you drop your team off over here. We're just hanging out and not working too hard. So anybody that wants to, yeah, thanks for the raid. And thanks for the raid alert too. If you guys got like a little raid message, you can message me with that. But yeah, we're just hammering out our system. And what we're doing is we're asking, the Socratic method is, can you do things? Ask yourself questions, and then can you figure those things out in the system? And we're just down here in the memory topics. And this one's actually funny. It's not it's not a good Jeopardy question, right? It's not in the form of a question, but can you generate high memory load for 3 minutes? And yeah, we're generating that in our system. We're looking at our free memory to see if it's going down. And this one would be stress dash maybe what do we say here? It was dash VM 4, and then we did timeout is equal to 180 seconds or something like that, right? So generate a high load on our system, see what kind of happens. All right, next one. So we're going to the file system topics next. And we've done these before. These are all up in the Discord, but every time I add more questions to them, we kind of go back through them and just say, hey, do I know how to do this? Hey, do I know how to do that? And honestly, I think a lot of people, I know I get a lot out of it when I go through these, but we'll just find good answers for things and make sure that we understand how our tools and how to check out our system, right? So we'll do. So the next one's going to be file systems. We're going to do some file system stuff. Sick in the mind. We were talking about this earlier. If you want to see just the most recent one, watch is great. The reason I use a loop is because I might want to look back, because watch overwrites the output every time, right? That's the only main reason. I am ambivalent to whichever one, like people should use whichever tool they're good with and which one they're good at. But it just really depends on what you want to see. And this may not be nearly as useful as if I did this. Watch, I might do this. Date. And then this. So this might be even a little more useful for me, because now later on when I'm looking at it, I can get down to exactly, the time. And then maybe I tee this off and throw this into a file so that another team can review it later. Mainly when I've done stuff like this live, because typically we also have like our Grafana monitoring going, right? So we are also tracking all this stuff in real time in Grafana, right? Typically it's node exporter being scraped by Prometheus and then Prometheus being shown over in Grafana. But that being said, by the way, this is done now, so look, the system's back to chilling again. But typically where I'm going with that is this is more, if I'm actively watching something like this, it's almost always because one of my dev teams has reached out to me and said, hey Scott, can you watch this while we spin up like a Java process? We've got this new, we're putting this new library into our older systems down in the dev environment, and they normally run on like 712 megs of memory or something. Now we want to make sure that they're staying under this other amount as we spin up like 10 whatever. But we don't have anybody on the team that really knows how to do that. We just know that we need to verify it. And I go, yeah, sure. So I'll watch this, right? I'll watch this over here, and then I'll give them like either I'll be on the phone or I'll give them a play-by-play, or I'll even share my screen and show them like, oh yeah, go ahead and load your servers up and let's see, is it handling the weight right? Is it not going over? We can add that stuff that we were looking at earlier, right? We can add the uptime as well. So now we can see the load across the CPU. Is there a high average? Are we waiting for things? Is it not hitting high CPU and starting to spin? If we really need to dig in, we can do IOStat, -C, and then we can dig in and see how much of the CPU is being used in user space or kernel space, right? Well, system space rather. User and system are both going against the kernel. It's just user space or system space, right? Or are we at a 99% idle, which is, we're not stressing the system at all. So you can not stress the system here at all, but you can be tremendously stressing the system on like the disk. Maybe you're writing to your back-end disks a whole bunch. So then, as we're sitting here talking, we're just watching this, right? But this kind of gets busy, like a -1 like this. So maybe I say only show me like X, I think it's XV, and it'll only show me, oops, X, maybe it's XZ. No. XZ, sorry, it's XZ, guys, sorry. And then we watch this one, right? And you go, what the hell's different there? Why is that not showing us everything? Earlier when you did this one, watch, you showed me all the disks every time, and I say, yes, very, very cool, right? But the problem here is none of these disks are doing anything, right? Oh, we're gonna get to file system stuff here in a second. Sorry, I'm still back. I'm still back here on load stuff. We're not in file system stuff. All right, but hold on. So I was gonna show you guys, if you go here, what's the difference with this one? Well, the first one shows all the output that's available. Watch this. That first one is all the output that's available. But then, hold on. Then it only shows the ones that are being written to at that time. So if nothing was being used, in this case, we're looking at C. Hold on. Add in disks. So now we're looking at the disks, but nobody's writing to the disks right now on this machine. And then if we wanted to spin it up and see where the load was going on the disks, we could do that. Even if they were in a logical volume management, right? We can see where they're actually going, where the writes are going to. Are they being striped? Are they heavily going to only one of these and not fairly going to the other ones? Do we not have the right type of array that we thought we did? There's all kinds of things that we can now figure out because we know how to use our tools. I tell you guys this stuff all the time. Like, I don't have to be super smart. I'm not that smart. What I am able to do is use my tools to answer questions to myself and figure things out. And that tends to be very powerful. Like, I wouldn't think, like, if I saw a carpenter that was really good with his tools, I wouldn't necessarily say, oh, that guy's super smart. I would just say he knows his tools well. And I think it should be the same thing for us as engineers. Like, we understand the tools. I can assure you this, CFG, it's all smoke and mirrors. Thanks for the follows, CFG, Cash Map, Sci-Fi School Sunday, Phoenix, and Gabriel. Hopefully this stuff's useful. We are just, again, not working super hard. I'm out of town right now. I'm normally in Phoenix. That's where I'm from. But I'm in Ohio right now. Dayton, Ohio, in fact, working on some supercomputers that my company brought out here for some of our customers. There's 3 supercomputers. I'm fixing little stuff in them to just make them that much better. We can do 95% of the stuff we need to remote, but they need me to sit around. Well, CFG, I'll give you the full sales spiel. Here you go. Here's our Discord. Oops. Discord's free. Don't charge anybody anything for Discord. Hold on. We'll go back to the file system stuff in a second. I'll drop the Discord link off for you guys over on YouTube as well. I like doing that. And the whole thing about it is we are a group. The whole reason I come online here is to show you guys that there exists a group out there. There's about 3,400 of us last time I checked. Where are we at? Yeah, there's about 3,400 of us or so. And what we are is the Professional Linux Users Group. And our goal is to take you guys from being maybe amateurs in this space to professionals. Maybe you want to get better at this. Maybe you want to go and do this stuff professionally, but you don't have the, maybe nobody's ever pushed you or told you you could. Well, I'm going to tell you you can. You just got to go work on it. Phoenix said, imagine one day I would actually master SED and awk and I would be unstoppable. I know about 5 things really well in awk, and I have to look up SED every time, Phoenix. And I've been doing this for like over 20 years, probably closer to about 22 years. So I bet if you asked anybody, they'd be like, Scott knows SED and awk really well. And I'm like, no, I just know like 2 or 3 things. Like probably 5 in awk and then SED I have to reference. But you don't have to be an expert in all things. You just have to know how to reference some things, right? So anyways, down here, this is what I was going to show you guys is we just ran through, so you'll hear people talking often about this Prolog project section. We just ran a 16-week course on getting into Linux systems administration. So it was this whole big course. It's all up here in Discord. It's all free. It's all on YouTube as well. It's all free on YouTube. Like, I don't charge you guys for anything in there. You guys can go do all that stuff all you want. But the point is, that's what we do around here. That's the goal of this group. That's why I get on here and tell people, hey, there's Linux and there's free stuff that you guys can go do. Is IOStat the same as using HTOP? No name. They give you different information. So I don't have HTOP on this system, but I can install it. Let's just install everything on this poor box. This box is abused. HTOP wants to install one dependency of this HW libs, whatever that is. This is what HTOP will show me. It will show me, it's very similar, HTOP is very similar to just top. It looks like I can see memory swap. Will it go to I/O? I don't know. Can I switch over to I/O? That looks like it's CPU. Yeah, I don't use HTOP, so H will show me. Hold on, let's see. Can I see? Does it show disks anywhere? CPU usage, memory swap. That's all good. Do we have any way to see disks anywhere? Gabriel, you said that's cool stuff. Do I have a channel like that for devs who want to go full cycle? No, we've had some guys that are devs that have been devs for a long time that have run a few different little projects in the Discord. The one guy who was really active, Salty Catfish, I haven't seen him for a while. I know him outside of streaming and stuff. He and I worked together for a long time, and he was really good. He showed people a lot of. He's mostly a Python dev, but he does basically full stack everything. And yeah, I don't know. I don't think we have anything in there right now that's super heavy on like full cycle stuff or full. If you're talking like full stack from front to back and even building stuff for, all the way down at the kernel level. But I've mostly been focusing on just straight engineering for everybody, and then the Linux side of things. And the thing that I might be doing next, maybe, is this. If I pull this up real quick. Where's that? Oh, I have it on a little thing, but I've been thinking of mainly doing like another little set of these projects. I think it'll probably be about a 9 to 12 week course on securing Linux. So that'll be my next one. It's like a securing Linux type focus, as opposed to just this one, which for people that want to see what the 16-week course was, let me go find my little Word doc on it real quick. It's called the syllabus. If you guys want to see what like the syllabus, this is what the syllabus looked like for that group, for people that went through it. And it actually officially ends on the 19th, so it's 10 days. But while I have been telling everybody go through it and do it if you want to, I would tell most people you're probably not going to finish it and get the certificate from it. Not this time around, not if you haven't already started it, because there's about 160 hours worth of work to finish it. But anyways, I'll show you guys what it looks like. This is the course. Gives a little description. We go down a little more. It gives a course summary. Talks about what we're doing. And then this is what I wanted to show you guys. This is the important part down here at the bottom. This is what we did for 16 weeks right here. These were our topics. So it's like getting into Linux, understanding the CLI, maybe a little VI, Vim, Nano. We were joking around about Nano. And then essential tools like files, redirects, permissions on systems. And there was a worksheet in the lab for almost every session, for every week. Gabriel, you said you do Python backend. I'm starting to dive deeper into servers and other things, not a lot of front end, so I will dive deep into servers plus backend, which is what people are calling full cycle now. Yeah, that's actually good. What I might tell you, Gabriel, this would be me. I'm not a developer, but you already do Python. What I would tell you, this would be my advice, right? Like if you say, hey Scott, what would you do? I would do this. I would move this out of the way. I would pull this up. Just get me a little web page here, and I would say, okay, I want to go with the most valuable thing. I want to go with the most valuable thing I can find to use my time with, and the most valuable thing, like if I wanted to move jobs right now, would be Kubernetes, right? Everybody's fucking talking about Kubernetes. Kubernetes is me down in the Linux world. Hey, thanks for that, Runamucker, giving out the subs so people can hang out with no ads. It's always kind of cool. We'll go right here, Killer Coda. Killer Coda, I think, is like one of the best things on the web right here, guys, if you don't know. And the reason it's so good is because it's free. Look, I'm not logged in. I'm going to log in. I'm just going to log in with my Google account because I don't want to bother with anything else. Now I'm in. I've paid them nothing for like three years of this. Never paid them a single thing. And I say, okay, I want to get ready for my CKA certification. I want to learn that a little bit, right? And I come down here and here's all this free stuff where I can just drop in like this. Look at this. Like, I'm telling you guys, there's nothing up my sleeves right now. I'm not even wearing sleeves. And I want to go learn how to look at kubelet status. I don't even know what kubelet is. I've never done Kubernetes before. I'm kidding. I'm a CKA and a CKAD, but I got those things because I came in here and worked on these. So this is free. Look, these guys haven't charged me nothing. You guys haven't seen me pay for anything. And now I am in a system that has Kubernetes running on it. And it's telling me things about it. And it's telling me to go look at kubelet. And I'm like, I don't know what a kubelet is. So then it gives me the command that would go and do a systemctl. Actually, this will run the command, right? And it'll go ahead and tell me, and then by the way, I can do that command again, but without that on it, and it will show me how kubelet is doing on the system. And then maybe I can go look at this. Maybe I'm a Linux guy, so I know, oh, I can do lsof dash maybe P for the process 1617, and I can see what that process is listening to. And I can go start digging in a bunch of stuff because I'm a Linux guy, right? And you're Linux guys too. And then you can come in here and you can, this is one of the best free things on the web right here, Killer Coda. I tell guys all the time, you come in Killer Coda, you go find this guy Scott. This guy Scott's great. You can just ask him, he tells you he's great. Anyways, he goes by Het as well. But here's Ansible. Here's how to learn Ansible if you've never played with it. So, yeah, Exoflexer, thanks for that, man. You don't, I mean, I'm cool with people just hanging out, but if people want to buy the book ties directly into the Ansible labs here and also the Linux labs that we have. So we have a bunch of labs that are free for you guys. Again, everything up here on Killer Coda is free. If anybody does buy the book, that's just cool for like, you know, it's cool, but nobody needs the book. It just, what the book adds color to is these labs here. So you can go and do the labs. There's 27 Linux ones, 21 Ansible ones. I've got some HashiCorp and some Kubernetes labs. So let's say you've never done Kubernetes before and you want to learn it. You come in here and you say, okay, Scott said that there's this thing called a canary deployment. I want to learn about a canary deployment. So you pop in here. Look, here's a free lab right here. Canary, boom. And then you say, okay, Scott, I want to learn this. I'm going to come down. He's got this picture, but it's too small to see. So you open it in a new tab, and you can make it as big as you want. You can scroll in and go, look at that. Okay, we're on step 1. Everything is going to my first version of my application called Canary. The service is pointing to V1, which is a deployment that has a couple of different pods underneath the deployment. And if none of those things make any sense to you, that's fine, because you would just go through it and figure this stuff out. Does that kind of make sense? Hey, thanks for that, Runamucker, giving the old gifted sub so you guys don't all have to watch ads. That's pretty nice. So I appreciate that. That keeps people from having to watch the ads. And I guess we can't say Twitch doesn't win, because Twitch still wins, but maybe it's a little bit maybe it's a little bit easier on everybody. But I appreciate that, Runamucker. I'm sure everybody else appreciates that too. So you come over here, and now with a Canary, so Canary is sometimes called a one-box deployment. That's what Amazon calls them. Or it could be sometimes thought of as a... Canaries are, we're going to deploy a new version of the app, but at a lower weight. In this case, we're going to be 80-20. Because we're going to go 80-20, right? And then we're going to come back and we're going to then be, when we're done, we'll be 100% over on one, and we're going to let the old app kind of shrivel up, down, and die. That's what we're going to do. And now you look at this picture and you go, well, that's a lot. Man, I can't remember all that. And I say, yeah, because you're just looking at it in a, you know, topology here. You're giving it a once over. Then we go build it, right? Maybe we come over here and we actually do the work to see how that looks, right? So we're gonna deploy, we're gonna look at the config maps and the different config maps. Oh man, Runnebucker, you're on a regular old tizzy there. Don't go all out for me, man. I'm just up in Ohio trying to survive a blizzard right now, guys. Yeah, you're on a rampage. You're doing the Oprah thing. Yeah, man, guys, I'm telling you, you guys will always think I'm kidding, and my wife thinks I was kidding. She was nervously laughing when I told her I almost died in a fucking blizzard on Monday. I am not lying to you. I tried to tromp across this parking lot to go to the other side of a mall to get to where the rental car place was, and it was only about 3/4 of a mile, guys, and I literally almost got stuck in the snow. And I'm a little older now, but I was an infantry guy. I can walk all day, you know? And this snow was up over my knees. And I was like, this is how the damn hobbits felt in The Lord of the Rings. So, yeah, everybody gets a sub. That's funny. So look at this. These are config maps, and config maps can hold files in them. And the files that I made are these little index.html files. So you guys could do this lab. You can watch me do it right now, too. But we're just going to look, and then we're going to say, okay, that's cool. Let's get out of there. And then we'll just run it, right? Deploy the resources. And we create these config maps, which are actually web pages. Hua, indeed, local Ken. Yeah, I was an infantry guy. Infantry guys are the enemies of everybody. We were talking about this last night, or the other night, we were talking about like infantry's natural enemy is the tanker, and infantry's natural enemy is the MP because they arrest us and throw us in jail. And then like infantry, everybody's their enemy. It's like that Willy, whatever. So, but you don't have to do all that, but I appreciate it. So now we did some deployments, guys. We can go look at these now. kubectl git deployments. We can see these deployments, and then we can say kubectl git nodes or git pods, right? And the pods names. This is a fun little thing if you're not familiar. Nginx deployment blue. The pods for Nginx deployment blue will always have the deployment prepended onto their name. So the two pods for deployment blue are right here. Now, there's other ways that we can find this. There's other ways that we can know this to be true, but they come from looking at the file and they look at some other things. But the point is, we've got these things deployed right now. We can go get just the config maps. We can get just the deployments. We can just the pod. Those are the commands we just did, right? So anyways, you're using this to learn and see the behaviors of Kubernetes. But if I wasn't emphasizing this strongly enough earlier, guys, this is free. This effing site, guys, I have literally deployed thousands of these labs and they've never charged me a penny. It is the best free thing on the web, I think, to learn system stuff. And you can sit here and you can chew on this for a while. And then you can be like, I could go to, so this is one I like to do. I show you guys this all the time. Let's say you're getting ready for a cert. You're getting ready for your CKA. And you go over here and you just say CKA GitHub. And you just find somebody, maybe GitHub notes, right? And you find somebody that has good GitHub notes. Somebody put together some study notes, right? Different guys. And one guy who always comes up for me, who I always show you guys, if he's around. I don't see him on here. Hold on, he might be on one of these other ones. He may have not updated it in a while, so maybe he's fallen down on the thing. Hold on, he's actually in one of my presentations because his stuff is so good. I don't see his name. We'll grab the next GitHub that we see. We'll just grab the next GitHub that we see. It's not any of these guys. None of these guys. And one of the nice things about GitHub is they're free, right? We'll look at this guy. I don't know if this is any good, but when he went to take the test, he put all his notes up there. So now, oh yeah, here's some good stuff. I can do kdescribe node. Well, kubectl, right? But that people alias it. Describe node, and then in this case, he looks for something. But maybe I want to describe a particular node, so I do Control-Shift-V in my little, this is a Chrome browser, right? And then now I can describe, oh, that's node. If I've got node, sorry, this is pod. So I can describe the pod Nginx, and it'll tell me about how that was deployed. And there's all these things that kind of get familiar with before I go study. Now, I don't know how all of you guys like to learn, but I know I would prefer to spend 30, 40 minutes playing around like this with stuff and typing commands in like this, and then go read about it for a little bit. And then when I get tired of reading about it, I'd like to come back and do this some more. That's one of the reasons, man, I'm telling you guys, I just think Killer Coda is one of the best. I think it's so good that I actually have 60 labs that are written in it, and so do a bunch of the other guys in our prologue, because what we want you guys to do is be able to get in there. Look at this. Have some of you, look, let's go look to Fisherman. Fisherman's one of our guys. He's got AI certs and stuff from Google. From AWS. He's got AI certs from them, and he also he just streams some, but he's been busy lately. And he wrote some really good little like junior sysadmin adventures labs that'll make you be a junior sysadmin for a little bit in Linux. But then he wrote this one, which I really like. It's building your own little local LLM. Some of you guys have never deployed a local LLM before. But if you want to do it, if you want to run Ollama and then put Tiny Llama on top of it in this little environment that they give you here, you can do that. You guys can just go in here, yeah, and you break it, and then when you're done, you guys want to see a new lab environment? I hit refresh right here. And it literally blows away the old lab. I never think about it again, and it comes up. Now, if you do that really fast, you might get timed out for a little bit. That's one of the costs of doing a free tool like this. You know, like, it's free. You can't abuse it because they're throwing away all that old stuff, and then they're rebuilding them. But yeah, you can come in here and you can just go, okay, I will figure out how to run this curl, and it will install Ollama for me. And then you could go in and you could do this other stuff. Runamucker, you said molecules kicking your butt? What, oh yeah, you were doing, is molecule the one, hold on. I was trying to think of this the other day. Is that the Ansible thing? Yeah, I always forget this. You were the one that showed me about this, wasn't it? Or you were telling me about running it. And then it's like, yeah, it's the thing to run. Yeah. Well, I happen to use a fair amount of roles, so Runamucker, if you need to reach out, just message me. I don't know if you're one of the guys on Discord, I'm sure, but you can always message me and I'll do it. No, Boris, you didn't. We were just going far afield. The Boris, we still have Socratic method going. I was showing some other stuff for a little bit. We'll go back to it. It's by the way, if you guys ever do miss out on the Socratic stuff and you just want it, you can go into it's down here under presentations, and if you scroll up just a little bit, it's not very far at all. Here's all the Socratic notes, and here's the Socratic method PowerPoint if you want them. So they're right in the Discord under presentations, and most of the time anybody that gives a presentation will give it to you guys. They'll put it up in here as well. So like my brother John, when he did his Kubernetes one, M-Pesa when he came in early December, he's coming to speak to you guys on Saturday. So coming up again, M-Pesa will be there. My Prometheus stuff for if you want to go get your PCA. I need to take my PCA. I haven't taken it yet, man. Hey Rossberger, how's it going? We're working on this thing. Well, one, we're building a little LLM so we can. Here, Ross. Before you leave, hold on. We're running a little Tiny Llama. So this is for you guys that have ever run or like talked to an AI. We're running our own one in a little free lab environment out in the web. So check this out. Right, we get to it. We pull it up. We build it. You can run other things other than Tiny Llama in Ollama. There's a bunch of other bigger models. You just can't run them on a machine that only has 2 CPUs and 4 megs of memory. So we're going to say, why is Ross Berger the best at everything he does? He should clip this too, because this is AI actually telling us in maybe a sing-song fashion, Ross Berger is done. Why is he the best at everything he does? He's an intelligent robot designed to assist humans in various tasks. He possesses a wide range of abilities and capabilities. Now, guys, this is our own little LLM. This is not a big one out on the web. This is our own little one that's completely contained inside of this little system we're using. So, Rosberg has been engineered to be safe around humans. He can detect and avoid obstacles. That is actually... All right. Sometimes we raid over to Ross on Sundays especially if he's on. But look, this is our own little model. It's inside. It's literally running inside the system. So watch. I'm going to hit Control D to exit this, and it's still running. So I can do like an ss-ntulp in Linux to see what ports are going on our system, right? And this one happens to be running. Hold on. This one happens to be running on port. Where's that port at? Hold on. Hold on, I see the port that's run on. Oh yeah, it's right here, the 11434 OLAMA, right? The reason I pull this up is because the next part of his lab says, well, you can interact, so you can have an API, so you can call it and you can say, why is the sky blue? And it'll come back and it'll tell you in a kind of weird fashion, because this is every single character one at a time, and this is kind of hard to read. So what we do is we fix this. I'm actually going to Control C this, and then we're going to go and we're going to add in right here this little part right here that says stream is equal to false, right? And then we need a comma after it, and then this will just say y is, we'll go back to Rosberg again. Right, so it'll be, why is Rosberg the best at everything he does? And it's going to take a little bit of time. It's actually going to build all that stuff that was coming actively in an interactive, what we call a, when things are happening at the same time, it's a synchronous message. This is a asynchronous message. We sent one, now we're going to wait for it to come back. But hold on real quick, check this out. This is now what we call a, oh, hold on, I'm trying to think of the model of system engineering that we're dealing with right here. Hold on, it's it's a long wait it's like a long pull instead of a short pull. Anyways, it gives us all the information out here, but I should be able to see right here that there's no one answer to this question, as it depends on various factors such as the individual's personality, skills, experience, and knowledge. About Rosberg. Anyway, so it doesn't know, right? Well, so I want to show you guys something else that's cool about this. Once you guys start building your little LLM like this, let's say you wanted to just run this in your home lab. You could run this in your home lab on a machine that has 2 CPUs and a core, or 2 CPUs and 4 gigs of RAM. Will run this because, right, you named nproc, and this is 1 CPU and free-m, so this is 1 and 2, so that's nothing, right? But I want you guys to see this real quick. In Ansible, Ansible's this awesome tool to go hit your stuff. So I can come here and I can scroll up. We got a lot of Ansible code for you guys to use if you're in our Discord, right? But if you go up just a little bit, let's go look for and yeah. So here's my little OLAMA reader that I wrote when I did this lab for the first time. So this is an Ansible, right? It's a simple little tool, right? You can go, guys, you can go pull this out of our Discord and use it if it's interesting to you, right? You come over here, you apt-y install Ansible. Boom, it's on there now. Boris, I have not taken the PCA yet, but I don't think it's super difficult. From what I've studied and read about, I just haven't taken it yet. So that's the Prometheus Certified Associate, guys. It is a 60 question test that you have to get 45 out of 60 right on. You got to get 75%. And I think, like, man, if you've read something like a couple times, I think you should get 75% on it, right? I mean, you've read the stuff, maybe you've built some Prometheus stuff out. All right, check this out real quick. I want to show you guys. So this is going to install, I'm just going to VI like llama.yaml, right? Or llama reader, doesn't matter. We're going to drop this in. And we're going to call our local host locally. And then up in here, we're not going to ask why is the sky blue. We're not going to ask what is the origin of Ansible. What is the origin of Ross Berger? He's still around, right? And now Ansible. Oh, there's one other thing we need to do here. There's a timeout of 90. We had to add the timeout of 90 because the timeout of 30, this tends to not respond. Then we say Ansible playbook, llama.yaml. It's going to read against our own system, and then it's going to give us out a response. I've never tried AutoGen CFG. I'm not sure what that is or if it's good. Ross is probably going to bed. Actually, I'm on the East Coast right now too. I'm in I'm on East Coast time. I'm not on the East Coast. I'm in Ohio. It's just East Coast time, so it's late for me as well. Ross Berger is an unreleased and secretive AI program developed by a company called Ross Technologies, which was later acquired by another private company. It is not clear whether or where it was created. It is believed that it was initially designed and implemented in the 1960s. I'm pretty sure Ross Berger told us he's younger than me, so he'd have to be in the 80s. The exact origins of Ross Berger remains a mystery, with some sources stating that it is in development as a weapon for use against potential enemies or opponents in battle, while others claim it was used purely for research purposes. However, in the end, the true origins and development of Ross Berger are shrouded in secrecy due to its top secret nature. All right, hold on. We asked a bot. We asked our own little LLM, and that's what it told us. Hold on. Where's Ross Berger at? Let's go find Ross Berger's stuff. Where can we put this? Self-promo. About the origins of Ross. And this was the answer. Our own tiny llama model and Ansible to request the API. Boom. It said that Ross was the best at everything he did. Oh man, more people are raiding. Thanks for the raid, guys. We're just hanging out. We're not working super hard. I'm dropping stuff in the self-promo channel to tell people about, man, where is this at? This is way too far up. And we asked about Ross Berger, and it said that he was believed to be generated for wartime purposes. So I'm sure he'll appreciate that when he sees it. All right, let's get out of there. Go down to our prologue, right? And anyways, we were playing around. We're using Ansible to hit a API that we built in, little API run inside of OLlama called Tiny Llama, and we prompted it to ask about Ross, and it told us whatever things. 8-bit Oni, you said thank you for showing this. Man, I'm telling you guys, I think Killer Coda is like, if you're telling me, hey Scott, I want to get better and I don't want to spend some money on Udemy or something, come in here, man. Like if you want to learn Nginx Ingress, here's somebody who wants to teach you. You want to learn some Podman, here's some Podman. Aqua Trivi, these are actually supported by the tool Aqua. Hey, thanks for that, Runamucker. More gift subs for everybody, keeping people from having to watch the ads. Can't let the ads win. But yeah, Raiders, I appreciate you guys coming in for the raid and hanging out. We are not working super hard today, so that's why we got the little penguin up. Also, I'm in a hotel room in Dayton, Ohio. I'm not at home until tomorrow night. So I'm just kind of showing you guys system stuff. In fact, it should say everywhere that we're doing the Socratic method. So I've kind of gone far afield from what I was trying to show you guys. But anyways, let's get out of here. Let's go back to the little Socratic method, where what I was showing you guys was, you're on a system in some way, and you start to ask yourself questions about what's going on. And we were at the file system topics. This was the next part. And the next question that we would ask ourselves is, can we show all of the use space in the /root partition? Hey, how's it going, Shrut Kapoor? Hopefully this stuff's useful to you. We are, again, just kind of hanging out and doing Linux, right? This is what we do. This is what my group is for. I want to teach you guys how to do this stuff. So yeah, we know how to do this. df-h on /. You can also leave off the H if you want. The problem is that's hard to read, right, for most of us. Yeah, Gabriel, spend some time there, man. You might find a really good, like I know people talk about Argo, right? Argo CD, and Argo's really cool. But I didn't know anything about it until I went over on Killer Coda and I saw a little thing for Argo, and I was like, I'm gonna figure out how to use this. And then probably about a week ago in our Discord, somebody said, oh yeah, I've been using Argo for this and this and this. And I could intelligently, at least I could understand what he was talking about because I had used the tool, right? If he had just said that stuff and I had just read some articles, I wouldn't know shit about Argo still. But because it was free, I was like, boom. And guys, I am a big fan of free, get your hands on this stuff, right? Like, the next, but I'm also a big fan of finding a group of engineers. I tell you guys all the time, if it's not my group, find somebody who does interesting stuff that you guys want to do, and then hang out with them. I tell you guys all the time, if you can't listen to me for one more second, then go find somebody you can, find somebody, but get involved with some group that's got the same type of goals as you. And our group, the goal is to get you from being a hobbyist. We're all hobbyists. We all do this for fun. And we want you to do this stuff professionally, right? I think Argo is built into people's pipelines. Yeah, I think people are using it for that. Yeah, CFG. Yeah. So guys, that's this is what we're doing. Yeah. So Gabriel, you're always welcome to hang out down there in the Discord. I tell people all the time, it's more, I don't charge you guys anything for it. I don't even know how to do that anyways. So my goal with you guys being down there is it's more persistent. You can talk to other people. Yeah, Phoenix, thanks for coming by. Don't be a stranger, but also you don't have to feel like you have to do anything to hang out with us. You guys are just welcome to be here if you want, So, yeah, Boris, thanks for coming by. So there's a lot of stuff going on, but we can see the system. Now it says, can we see the number of inodes used? Yeah, so we can do a df-i to see the number of inodes. But then this may beg the question for some of us, do I know what an inode is? An inode is all of the pointers, all of the values that our system has to point to different locations in memory. So it may not ever come up in most of your careers in Linux. I've been doing Linux for over 20 years, probably close to about 22 years now, professionally. I've been playing with it longer, but about 22 years professionally. And I have only seen inodes fill up twice in my career. And they were both times on a GPFS file system, which is a very specialized, big global parallel file system by IBM, right? That's the only time I've ever seen inodes fill up before space. Typically, you'll run out of space first, and most of you probably have never even thought of inodes. But you can run out of inodes. Let me show it to you. Actually, I think it comes up here. It says, can you show all of the used current space in the directory you're in? So you're in a particular directory on your system. We'll get to the inode usage here in a little bit. It says, can you show all of the used space current in the directory you're in? Do I know how to do that? Gabriel, really amazing stuff. Yeah, you're always welcome to hang out. This is what we do. This is all we do. We just hang out and do this stuff. Land Elite, I'm completely new to DevOps type stuff, but want to learn Docker first and then Kubernetes. Do you think that will add a lot of employment value? Oh yeah. Yeah, Kubernetes is probably one of the best things you could do right now for just being like valuable to the industry. I 100% think Kubernetes is one of the best things. I mean, if you don't want to just like do a bunch of AI stuff, and I'm not trying to shit on AI. Like AI is great. It's going to be around here for a long time. It's just, I don't feel like chasing the dragon around, man. I want to show people to be like good engineers. You can do good engineering practice in Kubernetes, just like you did good engineering practice in Linux, just like you did good engineering practice maybe over in Python or wherever you're at in your career for different people. But you will definitely see value increase. I read a thing a while back that the average person that has their CKA, now look, like don't quote me on this, but I read this. The average person that had their CKA was making about $175K a year. And that's US. Obviously, some of you guys are in different countries, and I don't know what that translates to in other places, but $175,000 a year is pretty good money, even in the US, even now. That's pretty all right. You're definitely well above the median. So there's that. Can you show all of the use space in the directory you're in? Yeah, you use a du command for that. And I like du-sh dot, and in the directory I'm in, there's not really much used. But if I cd over to opt and do a du-sh dot, I will see, by the way, I'm reading an NFS share right here, a lot more, 573 megs. And if I do a df-h on dot, I'll see that this is a mounted NFS file system. I'll see it's a mounted file system. I won't know that it's NFS, but I can find out that it's NFS. I can do mount grep for opt, and I would see that opt is actually an NFS 4 version mount, right? So there's all this stuff. Yeah, Land of the Elite. Look into that Killer Coda stuff I was showing if you were here for it. Killer Coda is 100% free, and it's like the best site on the web. Eliphaz said, what is the Socratic method? So the Socratic method is, I could ask a question to you, or you could ask a question to you, but we basically sit around and we ask ourselves questions to see if we know how to do certain things. So what we've done so far is we were like, can we tell how much RAM we have used? Can we tell how much RAM we have free? Can you tell me how much swap we have? And we just ask ourselves questions about the system that we're in. So right now we're use space inodes, and then we showed all the use space. Can I show? And we ask ourselves questions kind of like, the reason this is such a powerful way to learn is, let's say it's late at night and you've gotten a call out and you've got to do this stuff in Linux. You don't want to be trying to figure out how to show this stuff in the dead of night. You want to know your tools. You want to know how to do these things. Oh, AI would be a great, yeah, Land of the Elite. You could definitely use AI to bounce ideas off of. Yes, 100%. Yeah, this is just this one that I put together a while back. It's like 117 questions, and it's just, we built it, and we have the answers down here. Here's how you see these different things. This one's fun. Can you show all the processes? So I'm back here in root, let's say. Can you show all the processes that are using the directory you're in? This is fun. So if I'm in a directory, right, and maybe I'm trying to unmount that opt directory, right? So pwd, I'm in opt, df-h dot, and I need to unmount this directory on my system so that, I don't know, so that the system can then be rebooted, and then we can come up clean and reconnect. I don't know, who knows what we're doing late at night, right? Master My Fate said systemctl, maybe. I don't know if there's a systemctl command for this, but what I like to use is this one, lsof, on the file system that I'm in. And this will show me all the processes that are down in there, that are in that directory. Now, I often tell you guys, you're in the directory that you are, when you're relatively in a directory, you do pwd. Well, let me show you what I mean by that. Do you see this process ID of bash right here? Did you guys know in any command that you're ever in, if you echo $$, you will see the process ID of the shell or command or script or whatever you're in. So if you ever need to find that, you can. Well, look right here. Do we see that we are actually in that directory? Yes. Our bash shell that we're in is, bin bash, is this right here in the system. I can take it even further. I could do ps-ef, grep-i. Well, you don't really need the -i. And then for that number, and it'll tell you that that is bash. And then, I can go find the parent. What's the parent that spawned this? And that, I can just start going and digging further and further down. You don't need you don't need the -i, but you can search for just now the parent ID. And then now I see that sshd is what spawned my bash shell. Well, that makes sense because I SSH'd into this box, right? So, can I show all the processes in the directory I'm using? Yes, lsof will do that for you. Yeah, so SS actually, sorry, $, means a whole bunch of things. There are a bunch of other things, like I can do, watch this one. So echo $? And that will give you the return code of the last thing that ran. This is actually really useful because let's say that I looked for that number and I found it, but let's say I looked for a different number and I didn't find it, and then I went and did this, and well, okay, hold on, we gotta do this different. Let's just go, and we're gonna put a bracket around it. Don't worry about why the bracket's around it, and that's not going to give any output. And then when I do my echo $, now I have a 1. And you might say, well, okay, that's a 0 and that's a 1, but I can use that logically inside of scripts to say, well, if I found a process running, I can or cannot do things, right? I can do if-then conditions. I can test for false and true. However, you got to remember, this is inverted logic, so in this case, this is true. It did find something, and this is false. It did not find anything, but that's neither here nor there. But yeah, it's useful. Yeah, it's useful to see the exit code of the last run process. So, oh, and there's so many of them. Master my fate. There are, when you call a script, well, let's go to this real quick. Let's just VI some script real quick, right? And then let's just say I throw on the front of it bin bash. Right, so there's bin bash. And I might say, watch this, I can say echo welcome to my first script. And then I can say echo you called this with $1, and then echo you called this with $2, right? Let's just say as the first command line arg. Now this is not going to be perfect, but this is going to do what we need. There's a guy, one of our guys, Sending Grounds, who also streams. He will show you how to arg parse this better than me, but I just want to show you as the second command line arg. And I'm going to just execute this. So chmod 755 against some script. And then I'm going to run, so we'll cat some script real quick so you guys can see it. And then we'll run some script, but I won't do anything. I won't actually put anything on it. And you'll see they're empty. But now I'm going to say hello world, right? You know, the old hello world. And now the first thing that got grabbed became the first arg and was used. It was interpolated from a $1. Grab that first one. And the second one, delimited by spaces, went to that second one. Do you guys see that? So there are a tremendous amount of those $ things that you can go look at and dig into, right? But we got into that because, look, all that stuff we just talked about and did were because we asked ourselves this question right here. Can you show all the processes of the system in, right? So isn't that, I mean, I think it's kind of cool. Like, you can just sit around and ask yourself questions. So I was showing, let me show you guys something. Let's pull up a tool I was showing my college students last night. Some of you guys have probably seen this tool. Yeah, we'll let this, come on, get out of here. This is a tool some of you have probably seen before. Who's used this tool before? It's bright, I know. And let's pull up some capture from something of them before. Who's used this tool before right here? Who knows what this is? It's got a symbol, but it doesn't tell you what it is. Does anybody know what this tool is right here? You can tell me. You can tell me. It used to be ethereal, yep. Or ethereal, as I used to call it. But ethereal, right? It's Wireshark now. That's exactly right. But it was ethereal before. The same guy who made this tool, by the way, guys, if you don't know, the same guy who used this tool was the same guy who wrote Falcon. Falcon, not Falcon. Falco? Hold on. Now I'm confusing myself. Hold on. Where's this tool at? Hold on. With Falco. Yeah. He wrote this tool right here. Falco, if you guys have ever heard of Falco. He's the guy who wrote this. The same guy who wrote Wireshark. Well, anyways, hold on. This is what I was showing my college students. Because maybe this will be valuable for you too if you guys have used this before. Okay, so we've used this before and we've captured stuff. Yeah, Falco is the eBPF syscall tracer. Yeah, the same guy who wrote this packet tracer that's still used all over the world. Sorry, the Wireshark packet capture tool. It's used all over the world. Probably one of the most popular networking tools ever written. The same guy who wrote this wrote Falcon. So just so you guys know, if you didn't know, that's his company. He did open source it. It is open source. Falco is, and yeah, he came and talked to us a couple years back. I was at a Kubernetes talk, and he came and was our guest speaker. I was part of a Kubernetes group out here in Phoenix, which has mostly gone away. The guy who used to run it worked for a company called Drive Time, and we had like 175 people that would go to those. They were pretty big, and then he left and went to Microsoft, and they stopped doing the group because there was nobody. That kind of shows that power of like if you actually just start a group, people will hang out. Hey, Revisualize, we're just hanging out. Thanks for the follow. Yeah, I mean, it's the same thing with like this Prolog group. I've been running this group for 10 years, and we're up to like 3,400 people now trying to learn Linux and trying to get into this space. But hold on, I want to show you guys stuff. Let's say you're using Wireshark, and okay, you used it for college, right? I know who said Sci-Fi Sunday School said they used it for college. What if you use like the Socratic method and thought, could I just look at all of the real-time transport protocol? Do I know how to do that? Do I know how to apply a filter to only see like type, what is it? It's maybe I can't do it by that. I thought I could do it by protocol here. Well, I can do it this way, right? I can just order them, but maybe I do want time because time is the best way typically to look at things. But then I say just start asking yourselves questions. Do I understand what's happening on this call? Like, what is going on here? Well, we see session initiation protocol. Session initiation protocol, if I didn't know what it is, I can go look it up. That is how we initiate voice over IP calls between two systems, right? So SIP has, and then I might say, do I understand how SIP initiates a protocol to know that a 200 OK is good? 200 OK is the last thing before we start passing data. Yes. Okay, so SIP initiation was good, didn't break anywhere. Do I know what it looks like when it breaks? Well, this is not a breaking system, so now we get into real-time transport protocol. Now, real-time transport protocol is not secured. You need SRTP, which is secure real-time transport protocol, right? Now I look at this and I go, okay, can I figure out which two systems this was between? Well, I have it over here in the source and destination, but could I also come down here and look at it in the source and destination as actual IP information, right? Could I look at that in, this is a dotted decimal format, but could I also look at it in hex and understand what those values are? Good, okay. Revisualize said, do you still think meaningful to get into Linux sysadmin engineering space by just learning basic Linux? I've been applying to jobs for several months and I've been struggling to get a new IT role. Yeah, I still think there's a lot of value in it. Revisualize. We just ran a course and the course was free. I tell you guys this, like I always emphasize this up front because I know people are like, oh, it's going to cost something. No, if you go on our Discord and you go to Prolog Projects, we just ran a 16-week course on being a Linux systems administrator. Just finished it up like 2 weekends ago. It's free. I've got labs. I've got all this stuff. I've got a whole bunch of playlists up on YouTube for people that want to go. But people even did the little cat for me, cat jam. But yeah, there's 16 weeks of it. And it's just, this is less about being good at Linux, and this is much more about interfacing with Linux systems in the enterprise, which is what I was trying to show people how to do. So yeah, I still think there's a lot of value in it, Revisualize for sure. But going back to Socratic method, let's say something was busted here, or let's say I wanted to see this, and I say, well, could I go to, like, do I understand how to listen to this call? So there's a call that we captured, and it's not secured. So does that mean that I could play this call back?
Hello, world.
That's the creepiest voice I've ever heard in my life. Listen to this thing.
Hello, world.
Hello, world.
World.
You're creepy as shit, robot voice.
Hello, world.
Like Ghost in the Machine and stuff. Anyways, do I know how to do that? Do I know how to go to, so it's real-time transport protocol, so it's using UDP, so there's no following these streams. But could I go to a different one? So maybe I go look in like, this is a Kali one in my home lab. Bobby Tom raiding with a party too. Thank you for the raid. I appreciate it. We're just hanging out. This is another one. This is watching my home network. And what's going on in my home network? There's a bunch of systems that are just screaming out broadcast for address resolution of who has this node, and just, it's almost like if you've ever seen like the old time where the kids are standing on the corner just, paper, paper, get your paper, right? Like they're just yelling. That's what ARP is. ARP is a broadcast at layer 2, right? And can I go prove that? Yeah, look, here's a broadcast right here. Where's he at? Here's a broadcast right here. Destination broadcast, all Fs at layer. There's 48 ones in a row right there. Each of these Fs are 4 ones because they're hexadecimal. So that's 48 ones in a row broadcasting anybody that's on this network segment with me. Man, Runnemucker's blowing up today. Runnemucker wants to solidify that #1 place forever. I appreciate that. But you guys are always, I tell you guys all the time, you're always welcome to hang out. Runnemucker's just making sure you don't have to watch ads, so that's kind of cool of him. And you know, I'm on later than normal because I'm on the East Coast and just kind of doing it. I guess I'm not on later than normal, but I'm on later than normal for a guy that's on the East Coast because I don't normally stay up this late. The device might not want to find out the APIPA. 169, 123. Well, so these addresses can talk to each other in a network. Just so you know, like this is just the device configured itself. But if devices were on a network segment, let me think. They should still be able to communicate over these as long as they're not having to route anywhere, because these won't be routed. These are non-routable. 169. Well, I don't think they're by nature unroutable. I've just never seen anybody set up a route for them. But look, we've got all this stuff going, and what I really wanted to find here was the TCP string, which I know is down here because I started an SSH connection. And when I started my SSH connection, that happens over TCP. Can I prove that to myself? Yes. Everything that I could possibly click on here with SSH is going to be handled by TCP. So if you didn't know that, now you know. And again, that's still Socratic because you're saying, can I look at ICMP and do I understand what ICMP is doing? Well, ICMP is at layer 3. I know that it's using this ICMP echo, which is a ping request. And then it's getting back a set of replies, I hope, from some other nodes, right? And maybe I see this right here, and then now I should be able to follow down. 142.250 should come back, right? 142.250 should come back with a reply. And there's its reply right there. And if I couldn't find these replies easy, I should be able to come up here and start to look at, man, I am just messing up by the numbers here. I forget how to apply the filters. You can go find, you can actually, you can do the drop down and actually look at them. Ah, yeah, here we go. It should be source. These are ones that I've used before. I thought I could do test. Apparently I can't. The LSOF and the $$ kind of very useful. Yeah, Master of My Fate. Hopefully that stuff's useful to you. Yeah, I never remember the filters, but there are tricks. You can go look online. But also this is what I really wanted to show you guys when I was showing you TCP. I can look at TCP, and I know that TCP is a connection-oriented protocol, so it does a establishment with a 3-way handshake, which is a SYN, SYNAC, ACK, and then hold on, you have your connection that sends all the data in a sequential and ordered format, and then you've got a breakdown at the end with a FIN and a FINAC, right? Well, I can actually come here and I can say follow this TCP stream, and I can follow that all the way through. And I can click anywhere down here, and it'll move me forward on my little back here. And I can get all the way to the end, and I can see if, maybe I ask myself, could I prove that this TCP session ended during this window that I captured. And I would come right here and I would say, no, I cannot conclude that, because at the point that I stopped my capture, my SSH session between this was my Kali box 192.168.11.68 and 192.168.11.245, which is my home. This is my jump box and this is my Kali box. By the way, that reminds me something. Hold on. Can I get in that box now? So I don't think I have him. Hold on. Let's do an ARP-A, and is that guy back up on the network? Because I restarted that box the other day. I'll show you guys a trick here. And he was not. He didn't have a name yet. There's 92. There's 201. I know who that is. 254. That's that one that's being funky. And then there's a 65. Let's think about this. There's a 9, there's a 22, there's a 198. We know those guys. I want to see if this guy responds. Shouldn't be any of those, but maybe we'll try 92 just for fun. Well, he could be this. I don't think he's this 9 box. Because he's not really supposed to be DHCP. He's actually supposed to come up. Shouldn't be 22 either. Alright. Well, we'll worry about that when I get back home. But what I was going to do is I was going to try to show you guys that my little Kali box. And then we could scan the networks around and see what's going on near my home, right? But that doesn't really matter too much. Anyway, so my point in showing you guys this is you can take a tool, you can grab stuff that's going on in real time, and then you can ask yourself questions about it and go right back to the Socratic method just for networking and say, all right, I see that this is TCP, but I don't understand, what do I need to know here? Do I understand what these flags mean? Do I understand what a don't fragment flag means? And if I don't, maybe I got to go figure it out. Do I understand what's going on in this TCP stream? And maybe I want this was as ASCII, maybe I want it as the raw, what's going on for each frame. So you guys can, and then these are the ones that I've used before, right? I was looking for, so if you know your port numbers, you can start to look for TCP streams or UDP streams that equal certain things. So I might say over an hour at my company, do I have any TCP streams equal to 22? Right? What is that? Where is that at? TCP stream. Right, TCP stream equal to 22. That's weird. That should be there because the reason I say that is because the TCP stream is going to be destination port, so it might actually have to be destination port on that. Oh, another one. This is another one. You can come in here, guys, with analyze, and statistics is huge. You can just come in here and say, show me all the statistics for what was going on. And you can come in here and just figure out hey, who was generating the most traffic? And you can start to get, this is kind of this idea of looking at a histogram. What bucket took the most time? And well, this guy right here, this 168, whatever he was doing, he was using the most traffic. He had the most traffic in that time of maybe all of these things, right? And then out of all of the things, this is how it added up. And then you might say, well, that adds up more, Scott, hold on. That adds up more than 575. Yeah, well, because they're both of them. So this should be twice as much as the 575 down here, if that makes sense. Because this is just all of the addresses, and then this is how much of each from each half of the communication, right? So we can open that, we can do that. There's so many things. What was the one? I think you can look for errors. So you can, man, you can look for all kinds of stuff going on in here, right? But this one of these things, like you say, well, Scott, that's a lot. And I say, yeah, it's definitely a lot to try to learn late at night when there's a call out and there's a problem. If I was trying to get better at this stuff, I would spend maybe 15 minutes every morning looking at these and then coming in here and looking at stuff. Yeah. Revisualize. One of the things I tend to do is I know how to generate the PCAPs on the Linux side and give them to my networking team so they can troubleshoot stuff. But I want you guys to see that, like, you've got all this tooling to see what's going on in your environment. Destinations and ports. This is where most of the traffic was going in our environment. Port 22 was being used a lot, TCP. Port 22 is SSH. We were connecting across and talking. I knew that in this lab. In fact, this capture was almost all me talking. But it was also just me listening to my environment. Sorry, when I say talking, I mean over SSH between two nodes. That was a big part of what was being captured here. In fact, I think this one was specifically, see how it's called Kali.Scott? This was specifically captured from a Kali box. So, and the Kali box was the .68 at the time, so that's kind of good. I mostly hand them off to the network guys and let them deal with them. For me, I will gather stuff and I will filter it down if they need me to from like only a net or a range. But I don't try to become an expert in the tools anymore. Like, I'm not a network guy anymore. But if I were a network guy, I would want to know how to use my tools. Well. All right. How do we generate those on the Linux side? We go like this. We do like a. We'll go back to this guy. We'll do like a TCP dump. So we'll do like an IP-BR adder to see all of our IP addresses. Our interface is ETH0. Sorry guys, I'm squishing water bottles over here. We do TCP dump -I ETH0, and that will just dump. Whoops. Oh, we don't have TCP dump. DNF install TCP dump. Right. So for troubleshooting, this is super nice. Just install it. And then we'll run it, and we'll just see. What? Doesn't? That doesn't support monitor mode. Lowercase I. That's my bad. It's lowercase I. But now, hold on. That's a lot. And maybe I specifically want to know. So we see, by the way, we're seeing the SSH connection between Werewolf, how I jumped in here, and the node that I'm on, which is my dev node, right? So every one of these TCP dumps that's coming to the screen has to go to the SSH, like has to go over. So yeah, Runmucker, you're like on a roll. Nobody's got to watch that. People are gonna get really spoiled in here, Runmucker, and they're gonna be like, oh, Scott doesn't have any ads, and then all of a sudden they're gonna run out, and then they're gonna be like, I don't want to watch this guy anymore. He does like 5 minutes of ads every hour or something, and then it's gonna be a terrible thing. Now we can take this and we can say, well, I want to write out to a file temp, and then like pcap dot, we could do -date plus %f, and then maybe .pcap, right, or whatever. And now this will dump to that file. And the problem with this is working. It's doing all that stuff in the background, but then we're not going to be able to read it here. We're going to have to pull it off of the system typically. So now we got 20 packets. That was all we had because we weren't doing really anything else with it. But now we have this pcap, more temp pcap. By the way, you can't read this. You can't read it on there. It's in a pcap format, so now you got to pull that off, pull that down to wherever you're at, and then you've got to read it in Wireshark. We could pull this down right now and read it in Wireshark, right? It would just take moving this to my main jump box, and then since I'm in Ohio instead of over in Phoenix, I would have to then pull it out of my jump box with my normal user. Do you guys want to look? I mean, do you guys want to see that just so you can see, like, this is what sysadmins do, right? This is like Linux work. This is the kind of things that we might have to do in this world, right? All right. So check it out. We know where it is. It's on Rocky 5. I'm going to exit out of Rocky 5, and I'm just going to go to like temp on Werewolf, and I'm going to SCP from Rocky 5 at temp.pcap anything to here, and I'm going to pull it down. Then I'm going to chmod to be at least 644 that pcap file, right? Then I'm going to jump back over to this node. This is my main jump box environment here, right? And I will SCP from Werewolf. I might have to do this as the Scott user. And that's only because I think that's the user I normally jump in. I don't know. I don't think I have Werewolf keyed in my environment. It's weird. I think I did that for a reason. Scott at Werewolf, and then temp pcap anything to here. I'm kind of cheating a little. And then I need to know my password, which should be that one. And now I've pulled that down. So now I'm down in my, I should have been checking where I was, but in my HPC deploy, I now have this pcap. So I'm going to move it to temp pcap. Whoops, so we're going to move pcap to temp, right? We'll just move it over into my temp directory, and then cd to temp, and we will ls-l for pcap, and see how it's 644 still for root. Okay, now guys, I am remote, so I am not at home, but that is my jump box. So watch this. I'm going to go to my Windows. I'm on a Windows machine, guys. If you didn't know that, I'm on a Windows system. I'm going to SCP, because now, so the way we used to do it is we'd go to downloads. This is the way I normally do it. And I do scp.exe. This is an executable you can download just like Putty. You can download it from the same place where you get Putty. It's that Chiriac green end or whatever. So just like I was using Putty, I would get this pscp.exe. And then I would say, okay, we are schampine at prolog.asuscom.com, right? And I want to pscp the temp pcap anything down to here. Champagne at prolog asus. prolog.asuscom.com. What do you mean host not found? Hold on. That definitely worked. That's champagne at prolog.asuscom.com. Alright, we might have to give the full. But that, I mean, that shouldn't matter, but I don't know why that didn't work like that. But anyways, now I need to know this long password. Oh. Right, that's gonna pull my pcap to this system. Then I'm gonna pull up my Wireshark again, and I'm gonna say file open. I'm gonna go to my computer, local disk. That's annoying. Downloads, and I should be able to find. What's going on here? It should be all files because it's the most recent one and it's the pcap. But I should also be able to see it from that pcap right here. Does it not have permissions or something? Hold on, this thing's locking up. Hopefully this thing didn't take out everything, guys. Yeah, local Ken, thanks for coming by. I know sometimes you gotta bounce. I appreciate it. Hold on, guys. It's frozen up. Hopefully I haven't lost you guys. I don't think I have, because typically if my closed captioning is still working, I'm still talking to you guys. So. But no, sorry, not the Kali. This Wireshark is definitely frozen over here. So I might have to kill it. Oh, here we go. Oh, you finally decided to wake up there, huh, buddy? You weren't reading anything properly. It wasn't reading. Come on. Here we are hanging again. Trying to read disk, and it's just hanging. Come on, man. The file's like the smallest file anybody's ever seen. What's going on here? I just updated Wireshark the other day. I was gonna say I just updated Wireshark the other day, and if I hadn't updated it, I think it would have performed better than it is right now. Oh, come on. Jeez. Alright. Let's just look at the PCAP files. And it's going to be the most recent. Oh my god. Downloads. There it is. There's the PCAP. Alright, so this is all that happened in that little bit of time that we were sitting there. This is all that happened on that box in that time that we were watching it. I can see it was talking to the 25, so it's 55. It was talking to 25. There's a break here. Something happened. Something he tried to push to the low key, and something happened. We're seeing some kind of message here. Tried to use TCP. Maybe it got an unacknowledged TCP. TCP act an unacknowledged segment from before with Loki. There we go. Hey, Braga, how's it going, man? We were talking about, well, we've started out with the Socratic method, and then the guys convinced me, even though I'm in Ohio, I wanted to show them how easy it was to pull down. So we were in my home lab back home in Phoenix, and we did a full TCP dump, right? You guys saw the TCP dump, and then we saw that it was a mess. And then we pulled it back down, and then we pulled it over here. We pulled it down to my system here, and then we went to the Windows box and pulled it down here, right? Because I'm using a Windows laptop. And then we opened it up in PCAP to actually see and look at what's going on. And we can come in here, we can look at statistics and say, okay, how healthy maybe is like our throughput? Like, what's our throughput look in our system, right? And a lot of this stuff, you might go, well, Scott, is this good or bad? And I would say, well, good or bad is relative. And for the 30 seconds or so we ran that, I don't even know if we ran it for 30 seconds, I can't tell you if something's good or bad. I can just tell you that we can see what is, and we determine what's bad based on historical data or what we call the usage methodology that I often show you guys, which usage is the utilization, saturation, and errors of a system, right? So I come in here and I look at whatever's going on, and I start to figure out if things are good or bad, right? Yeah. Just the girl in tech. I wasn't doing anything too hard right now. We were just messing around inside of the Linux box, and we were pulling information back to, so this Linux box, all my Linux boxes are in Phoenix, Arizona, where I'm from. But I'm in Dayton, Ohio right now in a hotel room talking to you guys. And I went and did a TCP dump in my home lab, and then I pulled it all the way here to analyze in our Wireshark on my Windows box here in my hotel room. That's all I was showing you guys, is like, as a guys, and I didn't really emphasize this in the sysadmins course, but I say this often. You need to be able to push and pull data like you're copying files in a Windows machine. Like, how Windows, inside of Windows, you can do a Control-C and a Control-V and copy and paste everything. You need to know how to move data like that in the Linux world if you want to be a Linux sysadmin. And if you don't feel comfortable with it, well, let me know so that we can show you how to practice it, because that's the stuff that you gotta be able to do it. You guys gotta just, I tell you guys, like, you gotta just spend time in the command line like it's like how you want to do it. Because I tell you guys, if you can't look at this thing for 8 hours a day, if this bugs you right here, like looking at this, then honestly, I'm telling you, project management, marketing, fucking being in sales, like, is probably better. Because, guys, I tell you guys this stuff with my college students, right? And if you came to this stream and you watched me for 10 minutes doing Linux, and you hated it, and you said, I will never do that, I'm going to tell you guys right now, that's the best free thing anybody ever gave you. Because I have college students that have spent thousands of dollars in college to find out that they hate networking. And I'm like, don't you just kind of wish that somebody had sat you down in front of a terminal for 10 minutes and you went, ugh, this is gross, ugh. That meme that, ooh, brother, ugh, I don't want to do this. Wouldn't you rather somebody had showed you that? Because that's free. It took 10 minutes to show you that you didn't want to do this. I have students all the time tell me they hate command line. And I'm like, well, I honestly don't know what to tell you guys. Like, I can't I cannot promise you that you will ever be a Linux admin if you hate this. But if you have just the amount of sanity that I don't have, right? Because I've lost my sanity long ago. My brother John could tell you that. He's somewhere in the chat. He could tell you I lost my sanity long ago. But that being said, you have to just get in here and work on this stuff and learn it, right? And I wouldn't tell you just aimlessly do it. I'd tell you go do Killer Coda, go do all of these things that are out there for you to work on and get better at, right? This is the Socratic method we were working on, where we ask ourselves questions. We slowly ask ourselves questions and walk through, and then we take the conversations where the conversations take us, which is what we just. If anybody came in here lately and we're like, "What are you doing?" Well, that's what we were doing. Is we were walking around where the different conversations took us. Even though I haven't used Putty. Guys, I tell you all the time, I don't care what tool you use to get into Linux. I just happen to use Putty because I'm just lazy and it works, right? Why does my CLI? Oh, this was broken on purpose, guys. No, you don't have to love this. This is a mess. This was like the quadratic formula exploding, as Strongbad once said, right? No, this was me showing you guys that you can't read a PCAP file. Sorry, this was me messing around, guys. Sorry. Yeah, Putty's my tool of choice. Gosh, guys, this is one of the things I tell you. Like, I'm the most vanilla engineer I know. I don't set up anything. But down in our Discord, there's guys who talk about all kinds of other cool terminal programs. I think that's awesome, man. I wish I wasn't so lazy and would just like to go play. Like, I have this, like, I'll sit down and just be like, this is what I do now. So I'll stay in Putty until like the end of my career. Unless Putty gets like compromised, then I won't. But I tell you guys, like, down in our Discord, there's engineers that are doing all kinds of cool stuff in other terminals, and I have no hatred towards that. I think that's a really good thing to do, is get in there and work with these other tools and stuff. So yeah, like, that's the thing. Is the other thing too is, like, I don't spend when I go, I do a lot of what we call context switching, right? Like, where my company sends me, like, I'm in Ohio right now working on a project, and my boss called me today and said, Scott, we want you to be full-time back over on the NOAA project, which is the National Oceanographic Atmospheric Agency, where I've worked on and off since like 2020. He goes, hey, we want to put you back on that full-time. I said, that's fine. But when I context switch, what I mean is, like, this month I'm doing this stuff, this month I'm on another one. And if I spent 2 weeks setting up my environment, I got to move to another environment. So I basically am like, well, I don't want to, I'll offend half the people if I make a joke wrong. But you know that meme where, like, the president is sitting there licking on an ice cream cone? That's what I feel like. I just want to take my little vanilla ice cream cone and go sit in a new environment, and I don't need to, like, jump and build all these other things. So anyways, I don't know. Yeah, there's all kinds of ways to putty in the systems and stuff, and connect and terminal, and man, Moab term. Some guys like Moab term, which I just think sounds fun because it's like mother of all bombs, right? Living off the land, but for sysadmin. Yeah, I mean, well, guys, the environment I grew up in. Can I tell you how I grew up in systems admin world and systems engineering world? The default shell was C shell, and it was a Unix, HPUX, AIX, and Linux environment. Linux was much smaller than Unix in that environment. It was at Lockheed. It's kind of where I cut my teeth, really being a full-time Linux guy. And you couldn't move your environment between those different, like, servers, and then sometimes you have to jump up to work within it to help a guy who likes to use C shell or K shell. One of my buddies, I always joke around about this. K shell is KSH, and I have a buddy whose name is Kurt Scott Hayes, KSH, right? And yeah, they spelled his name right there too. And the funny thing to me was, like, I'm like, you still just use K shell because it's your initials, and he's like, yeah. And so, like, even as late as like 2014, when I was working with him, he was still using KSH, even though it's like, the times have passed you by. But you might say, well, does anybody use KSH? Yeah, if you ever install GPFS anywhere, the GPFS install scripts are still written in KSH. even as of last year when I did it, because I was upgrading a GPFS cluster for a set of nodes, and I was laying GPFS over 130 new nodes in a cluster, and yeah, you couldn't install without K-shell, which I think is interesting. All right, so can we go back into? Let's clear the screen. Let's bang SSH, which will take us to our last shell. It'll just bang, we'll just go, that's an exclamation mark. Bang with SSH will jump into the last box we were in, right? Instead of me having to go like history, grep, for SSH and find the most recent one or something like that. If you just know the command, this is a dangerous command though, guys. Be careful with it. Because if you bang the wrong delete or something like that, you may delete something you didn't mean to, right? So this is one to be careful with. But in my case, I just wanted to SSH over. So what's the next question here? Can you show all the processes? Oh, so we did this one, processes that are in the directory. Now this one said, can you check the long listing and can you explain the permissions? So what's a long listing? ls-l on root. Root. ls-l. Oh, and I just want the directories. So ls-ld root maybe. ls-ld on shadow. So temp. ls-ld on etc shadow. That's a file, right? And then you can leave the -d even though it's a file. Pass wd, and then etc ssh sshd underscore config. Right? Can I tell what all of these permissions mean? Do I know how permissions work? That's the question. That's the heart of this question. Check the long listing of all these, and can you explain the permissions? Also, fun one for people. Can you do all of this in one command? Can you do all these checks in one command? I'm going to clear the screen real quick. Actually, I won't clear the screen. I'll just run it. So I could do this. I could be verbose like this. What's up with Etsy Shadow? That's a fun one, right? Etsy Shadow can't be read by anybody. Do you know why that is? If you don't know why that is, that spins you off into a, what the hell's an Etsy Shadow and what's Etsy Shadow doing? Etsy Shadow is the place, by the way, normally you never show it to anybody, but I will show it to you guys. Yes, it is hash passwords, yep. And I will show it to you guys because this is a lab box that doesn't have anything important. Let's just head -5 on Etsy Shadow in my environment, because root can read it. And there's the root's password for this cluster node, doesn't really matter. And then here's some other passwords that may or may not exist for different nodes that may or may not be able to log in, right? But we can go and we can check that in Etsy passwd. Hold on real quick. I want to do something real quick. I'm going to say, could we do this as a fun thing? Could I do that in one command? Could I say for, path or for item in, and then say, root temp Etsy shadow, Etsy passwd, and Etsy sshd underscore config. Could I then say do echo I am checking $item, done. And if I can do that, I can do anything, right? Because just so you guys know, anything between do and done I can now do. So I can do here ls-l $item, right? And then now boom, I've done the thing that I just asked you to do, right? Does that make sense? And I didn't use the LD, but LD would make it shorter. But the question then, the heart of this question spins you off and says, do I understand how password or how access control lists for files work? Do I understand what this block right here means? It's read, write, and execute, right? And then this is read, write, and execute, and this is read, write, and execute. But do I understand who they're for? Has anybody ever shown some of you guys this? I bet one or two people have never been shown this, but I'll show you anyways. This is the user owner of the file. This is the user owner of the file. Here is the user owner of the file's name right here, root. This is the group owner of the file's permissions, and here's the group owner's name right here. And this is everybody else who doesn't need to be defined over here because they're everybody else that doesn't fall into everything else. Yeah, Sci-Fi Sunday, that's exactly right. User, group, and other. Yep. So the user permissions are here with a 4, a 2, and a 1 weight, right? That's what we call octal, 0 to 7. And then, so I can take this Anaconda kickstart real quick, and I could say chmod 777 on root Anaconda, right? -ks config. I'm just going to make it 777 on that one permission. Now, I said that this was octal between 0 and 7, and this is octal between 0 and 7, and this is octal between 0 and 7. So if I do an ls-l right now on root anaconda kickstart.cfg, I would expect to see read write execute, and read write execute right there, right? So if I'm not lying to you, if I'm telling you the truth and I'm not lying to myself, that's what should be shown. It should be read write execute, read write execute, read write execute. ls-l on root anaconda ks 777. But if I change it back, it was 600 for the permissions. It was on 600. That was the permissions that it was set to before. And I know that it was 600 because it was read write, which is a 6 and a 4 with no 1 for the group owner of the user owner of the file. It was no permissions for the group owner of the file, and it was no permissions for everybody else, which is undefined, right? So that's how that works. If nobody's ever shown that to you, there you go. That's how that works. All right. Chilling Spree, you are welcome to hang out however you want. I will never dictate how other people need to hang out by us. The only thing I ask is you try to do some Linux, right? I don't even, honestly, I tell people all the time, like, I really just care that you want to get better at systems in general. Like, if you're doing networking or security, you're welcome to hang out. If you're doing Unix even, you're welcome to hang out. Some guys are doing, we don't have too many kernel developers in ours, but we have a lot of guys who are developing other tools for systems. One of our guys, Salty Catfish, he was helping to rewrite a tool called XCat. He left our company because he worked with me. He left our company and went to another company to do, I think, more security stuff. But, you know, you guys are welcome to hang out. Like, I have guys that I worked with that don't work with me anymore that, you know, professionally we're not still connected. I mean, we're on LinkedIn or whatever, but we don't directly talk like that anymore, but we still hang out in the Discord. That happens pretty regularly for me. So, you're there. Yeah, Sci-Fi Sunday School. I try to show people a fair amount of network. I've been teaching networking at the college level for 16 years. So I taught at a school that no longer exists called ITT Tech, although it had been around for like 50 years when it went away. And I've been teaching at a school that's over 90 years old called DeVry. So in the US, DeVry is actually really well known for their electronics. But you know what's funny about it? If you guys ever go look up, oh man, I've been watching ITT Tech ads since the 80s when I was a kid, yeah. But DeVry, a lot of people don't know, they are responsible for a huge amount of technological advancements in the early, 1900s around motion cameras. And almost all like the motion camera technology that was used with film all the way up until probably even the last 20 years was made by DeVry. So, yeah, ITT Tech was out of Chicago, yes. Which is funny, I've worked for 3 different colleges that are out of Chicago now. That's kind of a funny little thing. I've never been to Chicago. I never plan on going to Chicago. I have no desire to ever be in Chicago. But I have worked for 3 different colleges that are out of there. So, that's actually kind of funny. Yeah, if you go look up the history of DeVry, the amount of stuff that they did was yeah, and I've never heard, somebody will post something about DeVry on LinkedIn and people will come out of the woodworks. They'll be like, yeah, I graduated in '68. And you're like, man, that guy's been an electrical engineer a long time. Because, a a good number of people graduated electrical engineering early on. I got my degree from there in 2006, my bachelor's, and that was in network communication management. So I already had a CCNA at the time, but I was just, you got to round out the degrees a little bit. I'm working on the doctorate now, so it's kind of fun. Although I'm in a pause right now, I might be moving to a different school. So. Oh, Local Ken, you're a DeVry alumni. Nice. Yeah. I'm an alumni, and then I've also been teaching there since 2016. So no, late 2015 I started there. So yeah, almost 10 years with them now. So. Revisualize said, how well do certs help land roles? I think so. Anything that you can put on a resume, Revisualize, is what I call a positive differentiator. Let me show you a couple things. So to answer the question was, how much do certs help you land roles? So let's say you have nothing on your resume. You have nothing on your resume that would make somebody want to hire you. Or maybe you've done some projects, you can talk a little bit. But the certs and the things that are on your resume help you get past like the HR and the AI, type things. So here's 6 certs that I know of that you can go get for free, right? There's one on APIs. There's one on chaos engineering. By the way, we've got a study guide for the API Academy stuff. So I think that one would take most people probably about 15 hours to study. Our study guide will help you, and you can go get. And then you just have one more thing to put on your resume. Chaos engineering is awesome for guys that want to do site reliability engineering. Also, it's really a fun topic. I've never had a interview in the last when I got this one in like 20 actually I got this in 2020 when Pesa told me to. So I've never had an interview since then where somebody didn't ask me about this. So that's a fun one that catches people's eyes. These are more just engineering. They're not straight systems engineering. They're more engineering and process management, total quality management type stuff. Six Sigma is actually a different type of quality management than total quality management, but you learn about the differences. And then IPv6, so you can go get an IPv6 certification. Every one of these certs, the training and the test is free. So the question about like how well do certs help land roles, I think they look good if you don't have anything else. If you don't have college, if you don't have a lot of work experience, get something on your resume. Get something on there that just when they go to cut and they're looking at the last 5 people and they all like the little pre-screen, they can go, well, you know what? Let's cut them on certs. Who's got a cert that's interesting to us? We'll give that guy a shot. And just have one more positive differentiator. And people go, well, what's a positive differentiator? Well, it's anything that's not negative. Yeah, this API one was excellent. I really enjoyed this one. There's 3 different components to it, and then you get a cert for each of the components, and then you get a final cert at the end. So this one was really fun. And then again, there's this one of our guys wrote a Pathfinder guide for it. So anyway, so we look at permissions. We need to know how permissions work. If we don't know how permissions work, we need to go spend time with them. I'm not going to spend a whole lot of time on them now. I was just kind of messing around with my looping. But can you explain all these permissions? You should be able to do that as a sysadmin. Maybe not all of them at first, but over time you will start to learn them. Also, you should know what this little D means over here, because you do not always have color mappings inside of Linux systems. You will have them often in modern Linux systems, but sometimes you will go to a type of system that does not have, or maybe the environment's messed up, or somebody removed an alias, and you don't have the colors to tell you that these are directories anymore. Well, the command line will tell you it's a directory right there. So, there's that. Oh, Minerva's Towel, you said IPv6 cert's a little funny. They were telling us that v4 was dead 10 years ago. I'm going to tell you, I was being told in 2006, well, when I was going to college, so I graduated in 2006, so 2004 to 2006, I was being told version 4 is out the window, version 6 is coming in. And here we are now, 19 years later. Kubernetes still relies heavily on IPv4. And Kubernetes is by far the most deployed thing on planet Earth, right? Like as far as like system stuff. I'm not talking about fucking desktops and that kind of stuff. That's all Windows, obviously. But But for systems work and for system workloads, definitely Kubernetes is the number one thing being deployed, right? Yeah, sticky and set GUID are also permissions as well. Revisualize, yeah. You can set those in there as well. They will change the permission sets typically. So yeah, when you set GUID and the set UID, what will happen is if you set them to like files, it will cause files to will be readable by others, and then if you set them on directories, they will cause the group ID or the user ID to stay the same based on when they're created or based on how they're created. I don't really mess with them much. I typically just reference them if I need to. And really what I do is I just set them and then I change them as I need to. So we do typically set GUIDs on directories if we want all files that are created in there to stay the same as the group ownership of the directory. It's a very common thing in like NFS type stuff. Because if you set the set GUID, it will stay. Files that are created in there new will keep the group UID in that directory. So kind of a nice thing to do. That is really not helping IPv6 case. Yeah. Well, NAT, even with NAT, we're still running out of, which is why almost all of your intra, when you leave your network between other networks, it's almost all IPv6. So like the backbones of things are almost all IPv6 nowadays. Most of you guys that are doing stuff, you're actually running over like a tunnel. You're using IPv4 locally, IPv4 out to like your modem, and then when your modem gets a hold of it, well, it can be jumped into any other protocol, but a lot of times they're exposing externally in IPv6. I know that's how like Cox and CenturyLink work because I have both of those to my house. I think you guys know, like I'm an engineer, I can't be down. So if Cox is down, I just jump over to my CenturyLink internet, and vice versa. Well, I've never had CenturyLink down, but if they have ever been down, I did notice because I was over on Cox, right? So that's kind of how that goes. Subnetting's still a good skill. I still show you guys how to do subnetting. I've been telling students for a long time, like subnetting will be gone one day, but I still try to show my students how to do it. All right. So anyway, Socratic method, we're over here. Can we do these things? Can you remount the temp directory as read-only? Well, let's see. df-h on temp, and we do a df-h on temp, and we see that it's mounted off of the /tempfs root of the system. Well, could we? We could very quickly say no, we can't because it's not mounted. But I could look a little more, lsblk, and I can see the block devices that are here. Maybe I do a block ID and see what. I don't see anything being used there. So maybe I just do this, right? Maybe I don't even partition anything. I just do something like this. I just make fs.ext4 on dev xvda. I don't even carve it up. I just put make ext4. What the hell am I thinking? ext4, and I just make a file system on that. And then I say mount dev xvda on temp. df-h temp. Now I've got temp, and if I do mount and grep-i for temp, I see here's dev xvda, and I see that it's read write, relatime, and sec label. But maybe I say, well, hold on. No, I've read before inside of CIS benchmarks that temp file system should be remounted, and it's read write right now, but I want it to be read only, so people can only read the files that I put there from somewhere else maybe. And then I want it to be no exec, because nobody should be able to execute things in that directory. So then I say, mount-o remount, and then I'm going to say ro and no exec on temp. And now when I do a mount grep-i/temp, so that it only shows the one, now I see that it's read only and no exec, so I cd to temp, and I try to touch some file, and it goes, cannot. And I say, but I'm root. I can do whatever I want. Well, you can't write on something that's read-only. You can't use your little Sharpie marker that you're using to etch into granite. You just can't. You can bang that Sharpie marker and you can mark all over the top of that granite. When I take a little polishing rag and polish it off, now it's not going to stay. So don't take anything for granted. Any of you guys remember that from Rick and Morty? How long have you been saying it like that? And then he snips his memory so he doesn't remember it. Oh shoot! All right. I love that stuff. I love Rick and Morty. I even have some of my little stuff when we're streaming where I'll pop it up. But we're remote, so we don't have nearly as much access as we normally do. I don't have nearly as much control, and I'm switching over to OBS from Streamlabs, so we don't see it. All right. Anyway, so let's say I wanted to fix that. I could just U-mount temp. Oh, why can't I U-mount temp? LSOF on temp. And I see, oh, it's because some idiot's standing in it. So I'll CD back out and I'll unmount it. And then if I do a DF-H on temp, it's back the way it was. All is right in the world. Nothing I did right there is permanent, unless I had put that into the file, into the etcfs tab and then reboot. Or if I had put in system D or something like that. So people have been asking a little bit about what is the Socratic method, what the heck is this guy talking about? We're just asking ourselves questions over here and then answering them and looking at systems. That's all it is. Then we're taking notes. This said, can you list the number of free inodes in slash? We did that earlier. df-I and slash. And slash is also just the root of the file system. And oh, we didn't do df-I though. -I is the number of inodes, and we have, 399,000, almost 400,000 inodes free. And I say touch test file. So touch temp test file, and ls-l on temp test file. And I can see that there is exactly one link to that file, one hard link. And it said, can you hard link to that file 3 times? And I say, I think I can do that. I do an ln from temp test file to temp test file 1. And then I link to 2, and I link to 3. Now, if you're looking, and I just did that 3 times, and I do an ls-l, I'm going to press up a few times. How many hard links should be to that original file? There was 1 before, and I just added 3. How many hard links are going to be to this file now? Anybody know? 4. Now watch this. Let's just real quick cat everything in temp with test in it. There's nothing in it, right? And then we're going to echo just 1 time. This is my 1 test into temp test file. Right? Just 1 time, right? And I'm going to cat temp test file, and I'm going to see it that 1 time. But now, even though I only put it in that 1 file, do you guys think it's going to be in all the other files? Yes. Now, if you say, Scott, well, that makes sense in some world probably, but I don't know what these hard links are. Hard links would be very similar to if you've ever been to a library and you went to look at the card catalog, or you looked it up on a computer and it told you go to this shelf to find this book, right? What's happening here, Minerva's Towel, you said, wait, is temp a RAM disk? Yeah, actually my whole file system is a RAM disk. My whole file system on this Rocky node, all my Rocky nodes, they are these stateless nodes that get rebooted and just come back up, and everything is run in RAM. Yes. Yep. Exactly what it is. So, hold on real quick. Back to this. This would be like if you went to temp test file, or you went to temp test file 1, or temp test file 2, or temp test file 3. If you went to any of those files, and you just said, show me the contents, you are going to the same location in memory because all of them are hard linked to the same location. So, watch this. If I rm-rf, I'm going to remove in the hardest way I know how. rm-rf, right? Temp, test file. Now ls-l on temp, test file, it's for sure gone. But test file 1 is still there. And test file 2 is still there. And test file 3 is still there. And the only thing that's happened is we removed one of the pointers to that memory location. See that? And if we look in there, if you've never done this, this is a good exercise. They're all still pointing to that same book on the shelf, or however you want to think of this from a memory location. I like to think of it from, like, you know, I grew up in a library basically. I was always in the library as a kid. So to remove a file system, or to remove a file from a file system, you reduce this to 0. So if I remove this one, and this one, the data that are stored here are now said to have been removed from the file system. Could you get them with a forensics tool before it's been overwritten in that location? 100% yes. But that's not... When you delete things from a file system, if there's other hard links, you are not actually like untethering them completely and kicking them off into the void. They are still tethered to the file system in some way, therefore the data are not deleted. So, okay. So can you link to it 3 times? Yes. And then can we delete all of them? Yes. And then it said, hold on. So I do a df-h and I see these other file systems and I say, okay. We've got this test file 1 still. Can I ln labs test file 1 from temp, we want to go from temp test file 1 that we still have into labs test file 1. We want to link that, ln. I was testing you guys. And it says I can't do that because, you know, it would be like if you were in my library and then Sci-Fi had a library across town and I was trying to tell you to go reference from this little location, the card catalog at the front of my library or my little computer, whatever you guys use. I was telling you to reference the thing across town at his library. You'd be like, that doesn't make any sense. How can I hard link to something that's not always there? How can I hard link to something that's not in this location? It's addressable memory. Like, it would be like if I said, hey, I live in Glendale, Arizona, and you live in Scottsdale. I'm going to give you the Scottsdale address in Glendale, Arizona. And you'd be like, there are no Scottsdale addresses in Glendale, Arizona. The addressable space of Glendale, Arizona is only the addressable space. You can't address things outside of it. I hope that kind of makes sense. I'm trying to hard link to something outside of my address space. This is one file system, / right? The root of the system. And I'm trying to hard link into something that's NFS that's different. How can their addressable spaces be inside of mine somewhere else? Does that kind of, hopefully that's clear as mud to you guys, right? You can't hard link. Can you soft link though? Hell yeah, you could soft link. -S. Now, well, it's a read-only file system, so now you can't. Fair enough. It's similar to how subnets work. Yeah, well, we can't because labs. Oh, I forgot. So labs are my read-only because I put labs in there that you guys can pull down into these and work on. So if you guys are looking and you're like, oh, that little Rocky 5 system is pretty cool. Anybody in our ProLug can get in our lab systems. We have 10 of these Rocky boxes. I have 19 of them normally, but because of we were doing some troubleshooting labs, right? I like showing you guys this because I think it's cool. So Rocky 5 is dev, and then Rocky 11 is test 1 or troubleshoot 1. Rocky 13 is troubleshoot 2, and then Rocky 15 and then the corresponding partners. So 11 and 12 are T-Shoot 1, 13 and 14 are T-Shoot 2, and then 15 and 16 are T-Shoot 3. So people that did the very final project of the Linux Systems Administration of last week, we had troubleshooting labs that you guys could do, where I made you guys go through, and then I posted the answers up in there too. So now you have the labs, and if you get stuck, you have the answers. So yeah, it's very similar Sci-Fi Sunday. Yeah, if you're in 192.168/16, you are not in the same place as a 172.16, slash 172.16.00/16. They're different networks. Yeah, because of significant bits. Hey, Robdom, how's it going? We are hanging out. It is late for me here. This is my last night in Dayton, Ohio. I'm flying out tomorrow in Delta, going down to Atlanta first, and then Atlanta over to Phoenix. So I'm gonna be dropping off the worst rental car I've ever had in my whole life. Oh, hold on, my things are broken. Let me pull this back up. I didn't realize those were broken. Pull this back up. There we go. Okay. Yeah, I am dropping off the worst rental car I've ever picked up. When I got the rental car, it was dirty. It was really dirty inside. When I say dirty, I mean like I wouldn't care if there was dirt. I'm talking like there was like McDonald's like bags in the back and stuff. And I'm pretty sure it smelled like weed, but it also needs the oil changed. It also sounds like it's dying, like it's knocking. And then I swear I was driving a little fast today, and there was actually like a burning belt or something. This is the worst rental car I've ever had, like by far, not even close. Yeah, Sci-Fi, thanks for coming. You guys are always welcome. Yeah, I asked for my money back. Robdom, I almost died getting that stupid car too. That blizzard almost got me on Monday. You guys almost heard Het Tanis frozen in snow. Found like a big polar bear frozen pop. Actually, a polar bear would have survived way better than me in that snow for sure. But yeah, I almost died in the snow. It was not good. Payment process running. Yeah, James, it's possible. Yeah. Things can be blocked. That's why I like LSOF, because then I can see what's blocking the system, and then I can get rid of them. Death by car rental failure, doctor. Yeah. D-Rough. Yeah. Yeah, Robdom, you got here late. I'm getting ready. I'm zoning down. But we were doing some Socratic Linux. We were asking ourselves questions, and then like one of the things hopefully that was apparent is even if it's not me, you can do this by yourself. These guys, these are all up in Discord, but you can ask questions like this, or you can just ask questions as you're playing with the system, and get almost into this. It's almost like a catch and throw. Like you're practicing your deductive reasoning about things. Is you check something, you validate it. You check something, you validate it. And as you do those kind of things, you zero in on how you troubleshoot things, because you can test things that are the way that you expect them. You can learn how to get into systems and look for things that are aberrant systems, right? Can you cat out the contents of the files that finds the mount point? So I exit back out. Let's go back to Rocky 5 for now, right? And then we go to cat etcfs tab. Our etcfs tab is defined in our cluster through a tool called Werewolf. And all ours really has is all of those tempfs file systems, and then it's got this NFS stuff. So there's all this NFS stuff that's there. And I look at it and I go, okay, that makes sense. And that should kind of align. It doesn't have to align, but it kind of aligns with df-h, because I can see the file systems that should be there. Now, this is not to say that this has to be the same. It's just in an unmodified system that recently rebooted, these are going to be pretty close to the same. There may be some stuff that stands up later, or an application, or a system process that mounts other things, and those are things that you should learn about your systems over time if you're going to be an administrator. But in the big scheme of things, we can come in here and we can just kind of understand what's going on. Because before I ever got to the system, if you asked me what was there, I'd be like, I don't really know. But now I could definitively tell you, here's our system. So if you started asking me questions, now, if you're talking to me as a college professor or as the guy who kind of runs Prolug, I might ask you questions in here to make you think, or you would be like, oh, he's trying to trip me up. No, I'm trying to get you to think about this. But a manager's going to ask you questions like, hey, I was told this system was full. Is our system full? And you come in here and go, no, we're at 45% usage. What the heck are you talking about? No, our disk is not full. But then they say, well, they were told they couldn't write any more files to our file system. So now you might have to dig in. Well, it's not actually here. Maybe it's on a different node, right? Maybe they asked for the wrong environment. Sometimes you got to go ask these probing questions and go figure stuff out. And I'll tell you, I don't care how far you get along engineering, you are still going to get pulled back into admin type stuff like that because people know you know how to troubleshoot. People know that you're the guy or girl that builds systems and you're the one who knows how to do this stuff. So they're going to ask you because, right, like they just think that we cast spells in command line. That's what they think. They don't know what we do. I tell people all the time, nobody has any idea what we do. I try to show it to them and then it just glosses over and they stop listening. So as systems admins, systems engineers, we learn these things. And I think an effective way is to ask yourself questions, right? This next one, can you test your write speed of your file system? Can you test your read speed? Do you know how to do that? You know, if I look at this and I say, okay, that's what people think we do, Quartz. They see us doing this and it's just like, you could try to walk them through it and it'll just be just them lollygagging around, and in their head it's just singing that Phenomena song because they don't hear a single thing you say. And this is like, and that's my technical college professor opinion for having like tried to show this to managers and PMs. I'll be like, look right here, and they'll be like, look at what? I can't see over the spells that you've cast. And you're like, it's a dev environment node. And they're like, I don't know what that says. And you're like, that says dev. And they're like, ooh. Again, thunder and lightning because they hear sorcery. Anyways, where am I going? What was I doing? So, mount grep-i home. Home is fine. I just want to see if home is read-write. Good. So we have an NFS type file system on home, and we have our tempfs on root. Right? This is a tempfs file system. So let's test our write speed into our file system. And we don't have a whole lot of space available, but we have a little bit. And let's just see how fast our system writes. Go to root. df-h dot. Yep, we're still in there. And I just do like a dd, which is disk duplicator. In file equals dev0. We just want to pull zeros off the processor. We don't want to do random or urandom because that'll increase other, or that will introduce other variables of speed to the system test that we don't want to do. And then we'll say the out file is root test file 1. And actually we can change that later, but that's fine, test file 1. And we'll say block size equals 1024K, which is 1 meg. And count is going to equal 1,000. So what's 1,000 megs? It's a gig, right? And we're just going to write this to the system. And just for fun, we can throw time on the front of it. So we're going to time our system for how long it took to write a gig out. Oh, 1.3 seconds. 1.3 gigs. It took under a second. It took about 4/5 of a second or so. And I say, well, that's good, but let's do it again. Let's test with test file 2. Test file 2, taking a little more time. A lot more time. What else is going on? Oh, what? Did I crash? Well, and that's how you crash the server, guys. So that was my goal, was to show you. No, that wasn't my goal. We just crashed one of my boxes. But here's the fun thing: when we SSH back in about, I don't know, we'll give it a few minutes. When he comes back up, he's actually just sitting there in that OM killer because OM killed the so we're getting a disconnect. Oh, he's not even giving us a connection. Yeah, see, he's still going to be up, but he's not going to be responsive. So I am not at the home lab to be able to kick that over. But I could go kill him at XCPNG level. Hold on. Which one is he on? 192.11.198. Let's see. I actually don't know. XCVM list. Who's on here? What nodes are on here? Rocky 10. Okay, so we need Rocky 5. Where's Rocky 5 at? Where's that little jerk at? Some of these nodes are halted. Where's Rocky 5? We can actually find, we could grep for him, but here's Rocky 5. And here's his UUID. And we're going to need his UUID in a second here when we kill him by doing XC host-reboot. So XC host reboot of that guy, right? Oh, hold on. I did not mean to double click that. It wouldn't matter probably, but one, okay. What? What am I doing wrong here? It might have been. Here we go. I think that was when we actually got it to work. Okay, so that's gonna reboot him because I don't have my little command. You guys have seen me do like my command line stuff, or sorry, my in the GUI type stuff, but I gotta go do it at the command line. Oh, he's down. Alright, we're going to wait until he comes back up, and then we'll go over there and we'll see him. So, yeah, hopefully this stuff's useful to you. Yeah, control byte, we've been far afield. We've been doing a lot of stuff. Mostly when I get on like this, especially when I'm in Ohio instead of Phoenix, I tell you guys that, you know, my goal is to get you guys into doing Linux. My goal is to get you guys down playing around with this stuff in the you know, with other people that are looking to do the same stuff, and then hopefully helping you to get into doing this stuff professionally. That's the goal. And it even says it down in our little nightbot there. So yeah, so we crashed that box because these nodes are a little more fickle, especially with the RAM FS. So we crushed the RAM on that box. And then we went over and we kicked it over. And that's fine. So could you test your write speed? It was pretty fast. Could we test our read speed? Sure. We could also do it out to our NFS and that kind of stuff. This will probably take, I think, about a little under 180 seconds. So we were about 20 seconds in when I started it. So I would expect these to start responding here in the next, I don't know, minute or so. Probably about the next minute or so this will start responding. We're getting destination host unreachable, which is fine. But soon we will see a response. And typically when we see a response, then we'll have a little bit of time as the system finishes standing up the kernel. And you might say, wait a minute, why does it get an IP address? Why does it get an IP address before the kernel comes up and starts networking? And I say, that's because of how iPXE works. So sometimes you'll actually get a response on these boxes for a little bit, and then it'll go back down because now the kernel's up and it's not responding on that anymore. And then when it gets to the networking and turns the networking on, then you get pinged. In an older physical server, sometimes between the time the network came up and then the SSH daemon might have been a few more seconds too. But nowadays, most of the time in virtual boxes like these, once networking's up, you're only a few seconds from SSH. At least that's been my experience of many years of running labs like this. Grab more water, guys. fridge here. Drink a lot of water. I got fridge like right at my feet here, so I can. There we go. There's our sequence response, and we might be able to just SSH right back in. Rocky 5. There we go. It's back up. Uptime pretty low. So if I asked you, we look at this and we say, hey, that dev box Rocky 5, did he just reboot? And then you could very definitively say on the call or on the bridge, yes, that node did just come. It did reboot. It did just come up. I see some CTL. What is it? It's list broken, I think. Not list broken. List failed. Well, I was just so I always do system CTL list unit state equals failed. That's the one I do. There's another one. Oh, maybe it's just failed. What? List units. There you go. So if you want failed, somebody also showed me the other day. I think you can just do failed there. Is that right? So are the somebody help me out here. Was there? Is it just dash failed? Somebody showed me that the other. Yeah. So you just do failed like that. List unit state failed is more verbose, but then failed is there. So I could look at this and say, okay, the system came up. I don't see anything failed. If I were to, I don't know, demessage grep-i for error. I don't see any errors as the system came up. We don't have any glaring obvious errors here on the system. Obviously, I can get in it. So if I can get in it, that means that the network's up, right? Because I was able to SSH over to it. So I'm not really seeing like errors on this, and we know what caused it to go down. That was us, well, me. So there's, these are the kind of things we mess around with. So, all right, I will probably find somebody to raid here, guys, because I'm pretty beat, and it's almost 11 for me here this time. So I'm not gonna get to bed as late as I did last night, but yeah, if you guys want to hang out in the Discord, here's the Discord. I don't know if Robodom's still around, but there's Discord. You guys are always welcome to hang out. There it is over on the YouTube side of things. Yeah, and then just hopefully you find some, if it's not us, find some group somewhere of people that have similar goals as you to go and do Linux with. Go, just Linux, or I don't care. It could be Rust. But those Rust guys, man, they're real. They stick together real well. Those crap guys, they stick together real well. But maybe, maybe you find that you really like Kubernetes and that's the goal you want to go. Or maybe you want to be a security guy still. You see all the terrible things in security and you still want to be a security engineer. Go do it, right? But my point is, find some place that you can do that. If it's us, cool. If it's not, find somewhere. Doesn't matter. All right. I've preached enough. Let's go find somebody to raid on the Twitch side of things. On the YouTube side of things, well, James, it's possible. Let's go raid back to Hack Smarter. He raided us last night. We're gonna raid back to him, and we'll go back over there. And if you guys like this stuff, here's the message we tend to use. We use the do all the Linux message. So we'll go right over there, and I will see some of you guys probably not tomorrow night because I'm flying, but definitely this weekend. We've got some good events coming up. So come hang out with us, and I will talk to you guys later. Take care.
Find the one for escape.